Ahem. Hello, good morning. Game dev time. It's Saturday. Yay. Get this going. Okay, there I am. Hello, YouTube. Hello. Nice. Mr. Famous. Hello. Hi, buddy. Good morning. The puppy came in to say hi when he heard me talking. Okay. What are we doing here? What are we doing? Boot up the engine here. What do I need to do? Okay. Should have tested this before I started the stream. I wanted to change some of my audio settings. We'll see how that goes. I have a noise gate in OBS and in like my Wavelength software, so I'm turning off the one in OBS. We're gonna see what that sounds like. I did notice briefly watching back some of the streams, like some of the words I say get cut off, like at the end or beginning. I think I'm aggressively noise gating when I don't need to be. We'll see. Yeah, so I fixed all my dynamic nav mesh issues, which is great. Which is great. The silliest issue. there were two issues. Well, I guess three. There were three total issues. Well, now I can show you that it's working now. So, what was happening? I have a dynamic nav mesh, and I have a dynamic mesh component. They are not related to each other. Quick play of my test level. There's my nav mesh, and look, we have navigation on it. Beautiful. So problem number one that was happening was that whenever a dynamic nav mesh, like the one we're looking at here, this is generated from some of the noise stuff that I have, whenever that got built for the first time, it would not generate navigation on it. And that was probably the hardest one to figure out. But I guess what ended up happening there was that it's because I was cooking the physics body setup async. And so I guess when you do that, when it's done async, the physics state gets created after the navigation has been updated. And there's this nav relevant interface that every component has on it. And I ended up overriding several of those functions. And I just needed to override, this isn't one of those functions. Let me actually... but I ended up overriding this onCreate physics state because I noticed that the tri-mesh geometry never got populated in the body setup, which is what I figured out was eventually being copied over into the nav mesh geometry, which was very difficult to find. I was just breakpointing literally everything in the nav mesh files. But yeah, that was never populated. And so that's when I finally did this like a get body setup. I was like, okay, why is the body setup returning the bad one? I need this good with this. Because the dynamic mesh component has like its own body setup that it hangs onto separately. And I was like wanting to ensure that that was the one that was being returned. And it was. But then this get body setup would get hit after all the nav mesh stuff happened. And then it would have the tri-mesh geometry. And I was just looking at the stack trace, and it was like this whole, it was like this create physics state stuff. So I was like, okay, maybe there's a function I can override. And I figured out about these two functions here that can manually kind of trigger a nav mesh update, which I don't know that I need both of these. I think one of these I can probably get rid of. We shall see. We shall see. But doing that led to this being built, because like before it would only build when you would like move it or something, you know. Okay, which now it's very laggy, and I didn't actually test this very well before, after I figured it out. So we're gonna go through and kind of clean it up a little bit now. Oh, okay, yeah, perfect. So that's one issue figured out. Hey, Reanimated Man X, thank you for the bits, my dude. Welcome in. Happy Saturday. What are you up to this Saturday? I'm doing some game dev. I figured out some issues, and so we are unblocked and we're going to move forward, which is great. One of them, this dynamic mesh, wasn't generating a nav mesh on it. Figured that out. Another issue that I was having was that I would move this and it would rebuild the entire nav mesh, which is not okay, right? And essentially what that would mean for my procedural terrain would be like whenever I spawn a new one in, all of the dynamic mesh chunks would regenerate their navigation instead of doing this where it only regenerates the necessary ones. Yeah, definitely suboptimal. Now the worst issue I was dealing with, that was the most suboptimal, was that when I was working on this last stream, I think this is what I was working on last stream, was anytime my player character moved, it would regenerate the entire nav mesh. And yeah, can't have that. That's horrible, right? And that was actually a massive pain, and it was the silliest issue. And you'll never guess what the issue was. I didn't even know if, like, I was like, okay, does the dynamic nav mesh just not even work that way? Like, I ended up trying, I created a new project and tried a new character, and it wasn't regenerating the dynamic nav mesh. I was like, okay, so it should work that way. And then I was like, just trying to pick apart my character, just like deleting shit left and right. I ended up creating a new character in my project, and I was like, okay, it's got to be something to do with ALS, right? The advanced locomotion system that I'm using. So started trying to build just a blank character with that, just doing like the bare minimum. And yeah, it was still happening, but it only started happening when I put on an animation blueprint onto the character. No animation blueprint, but still moving around, wouldn't rebuild the nav mesh. Good, that's what we want. So whenever my character would animate, it would rebuild the nav mesh. Not what we want. And so I was like, okay, I guess I'm just gonna have to start deleting shit out of this animation blueprint. And so yeah, I just went disconnecting literally every single thing until I got all the way down in like the base, like locomotion movement stuff, which is like pretty deep in there. If you've ever used ALS, it's a pretty nasty plugin. Very powerful, but very complicated. And there was this, like, maybe I can show it. Maybe I can show it here. How many hours did I burn? Oh man, at least 10. At least 10. For all these issues combined. But I was in locomotion. Where was I? I was in here. We were in here. Locomotion states. No, this wasn't it. Wait, where was I in? Oh, it was in standing. Right. Okay, it was in here. Okay, so we have this anim graph here, right? We have these movements, this move state here, and I'm looking. And I was like, literally, this is where I got. I was disconnecting every single pin, trying to figure out, like, if I disconnected it, when would it start working, right? And so, like, I disconnected one of these. I disconnected walk, run, forward, which is like this blend, kind of complicated blend splice. That's what we're gonna say. And it would not rebuild the nav mesh when I walked forward, but it would when I would go backwards, left forward, right forward. You know, when any of these other ones would get hit, it would work great. And so I was like, okay, let me just plug in like a random animation in here. Let me just put in the walk forward animation in here. Same thing, it would rebuild the nav mesh. I was like, okay, let me grab a different ALS animation and put it in there. Still, same thing, it would rebuild the nav mesh. was like, okay, let me just grab some other animation. Just from I grabbed like the default walk forward Manny animation and plugged it in here. Finally, it started not rebuilding when I would move. Crazy. I was like, okay, what the hell is the difference between these two animations? Why is one? Why is animation even causing my nav mesh to rebuild? That's ridiculous, right? Like an animation blueprint or an animation should never affect the nav mesh. It does not make sense. You're right. It does not make sense. It doesn't. Why is that happening? So I had these two animations side by side. I'm looking at all like the checkboxes. You know, I'm making everything look the same. I'm noticing on the ALS animation that is causing the rebuild, it has some curves on it, and maybe I can pull it up. Maybe I can pull it up. It was walk forward. Right, I was looking at this, right? That's crouch walk forward. Should be same thing. It has these curves on it, right? I was like, okay. Again, curves should not be affecting the nav mesh, but I'll delete them anyway. Delete them. Same thing still happened. I was like, okay, what else is different? Okay, we've got these animation notifies here. I guess I'll just fucking delete those. And yeah, guess what? Deleting the footstep animation notifies fixed the issue. Isn't that nuts? Why did that fix the issue, you ask? Because apparently these footstep effects, they spawn like these little footstep decals, and ALS has a setting that attaches those to the object that they come in contact with. And apparently doing an attachment on a component that can affect navigation causes the navigation to rebuild. So it was literally the fucking footstep decals were rebuilding my nav mesh every time. And the decal component itself was even marked as cannot affect navigation, but it would still, because it was being attached to something that did have can affect navigation true, it would rebuild. So yeah, oh my god, indeed. I was just like, I kind of laughed whenever I figured that out. Yeah, it's crazy. It was the silliest fucking issue. But yeah, here's the footstep effect settings right here. So you can, where is it? The decal spawn mode, spawn at trace hit location or spawn attached to trace hit component. And what is it? Footstep, yeah. In here. Right here. This is the line. This is the line that was doing it. So yeah, I saw this. I came in here and like I literally like I had to walk through, you know, all this code to find this, but finally saw this setting right here. I was like, okay, there's a setting somewhere that I can find. Ended up finding the setting, and I opened an issue on the repository for it, just saying like, hey, we should probably, let's not default the setting to spawn decal attached. Let's default it to spawn at location. That way people don't have the same issue as me. But yeah, I'm very glad I figured that out. Silliest issue though. That might be top issue for silliness that I've dealt with. So yeah, we figured it out. There was a third issue, and that was you know, one issue was the nav mesh rebuilding every time my player moved. Another issue was the this dynamic mesh we're looking at here. It would never spawn with navigation on it. It would only, the navigation would only generate on it after you like moved it or changed a setting or something. Fixed that issue. Talked about that just a second ago. Third issue was that whenever a dynamic mesh spawned, it would rebuild everything. Or whenever a dynamic mesh moved, it would rebuild everything. Instead of just, you know, the locations that it's near, like that. Like this is correct, right? Before it would this whole thing would rebuild. And apparently, because it's a dynamic mesh, the bounds. I found this nav relevance interface. So there's a bunch of functions I ended up overriding. Most of them I don't use, but the get navigation bounds. After stepping through the navigation code for hours, I figured out that the bounds were just abnormally large. I think the bounds were actually set to the size of the nav mesh. Like that might be the default when you can't get bounds directly from the component, which when it's a dynamic mesh component, I suppose there's some reason. Don't exactly know, but there is some reason, I guess. It was doing some pretty complicated like bounds calculation, like some AABB type thing that didn't seem to be actually working. And that may be because it was saying something about it doesn't take into account, or rather it does take into account indices and vertices that aren't actually used, that exist. So I'm wondering if that was throwing it off somehow. But I do happen to just know it's a very easy calculation for me, the bounds of my terrain chunks. And I just kind of like spoofed that out here to test, see if that was the issue. And yeah, that's the red debug drawing there. So that ended up fixing that issue. So that's anyone using dynamic mesh components, that's a tip for you. Make sure the bounds are correct, the navigation bound. And then you'll need to update it here when the get navigation data is called, because that this out data is like, it gets calculated and stuff, so you got to set it on there. But yeah, that fixed all my issues. Now I got to clean up. I need to figure out which one of these two functions I should be using. I need to figure out if I can I could probably delete this. It's gonna be my first test. Let's delete that and rebuild, and we'll see if we still work. I shouldn't need clear flags anymore. That was not the issue. Let's actually delete that. I thought clearing the async flag would help. Didn't make a difference. Yeah, that was a doozy of a day. I figured that stuff out yesterday. Yeah, very, very happy to move forward with that, because now I can actually spawn things in the world and have them move around and stuff. Which is what a nav mesh is for, if you didn't know. See, like this right here, where it's like recalculating every tile, that would happen every time I moved the dynamic mesh. Okay. Do it have nav? It do. Okay, so let's move it. Okay, cool. So we didn't need the get body setup. It was indeed returning the right one. Wait, and then that doesn't exist anymore. Did I get it old? This might be an old build. But let's get rid of that and see what happens. Okay, we're good. We're good. And just as proof, the character can move now, and it doesn't regenerate the nav mesh. Okay, and so these are like functions that I found on the internet for just updating the, like manually updating the nav mesh. I'm gonna guess this one isn't needed. That one seems less trustworthy. I'm gonna try without that one. See if everything still works. Okay. Okay, yeah, it still works. Okay. And I know, does either one work? Let's try the other one. Does either one work? Your game is an MMO, right? Yeah, we'll go with that. It's not an MMO. Okay, yeah, it seems either one works. So they both serve the same purpose of updating component data or updating component in nav octree. Okay, see, so this is the issue, right? It doesn't have navigation built on it, but when I move it, it'll recalculate. We can't have that. We gotta have at least one of these in here, so we'll keep that one. A lot of these we can get rid of now. Is navigation relevant? Didn't end up needing that one. Get rid of that. I will need to calculate that properly. So no server component, only the default one. Yeah, I'm not 100% sure what the multiplayer setup is going to look like yet. I've only kind of just dipped my toes in that a little bit. I kind of want to get all the base systems in before I'm still just in like make it work mode, you know? So once I get all like the base systems in, then I'm going to go back and do a multiplayer pass, get everything working there. And yeah, I do want it to be multiplayer, and I do like the idea of being able to have a dedicated server, could you so choose. But yeah, we'll see how difficult it is. It would be nice to have or be able to think about performance in terms of a dedicated server, because then I don't have to worry about like expensive code running on the client, right? You can just get a beefy server and deal with it. But I think definitely like a peer-to-peer setup. What is that called in here? Like a client as server setup should be possible as well. It would be nice to have both. It would be nice to have both. Okay, so this is my custom dynamic mesh component. Yeah, so how am I gonna calculate the bounds generically here? Because it would be nice to not have this have any knowledge of it being a terrain chunk. But then that's just gonna, I'm probably just gonna get back to the same issue where I have to do a somewhat complicated calculation for the bounds. Maybe I should override this in a subclass. Like I'll have this my dynamic mesh component, and then I'll have like a terrain chunk dynamic mesh component or something. Which is what my LOD mesh was before. So maybe I'll reuse the LOD mesh. Yeah, because I'm not using this at all anymore. Class is effectively dead. Okay, yeah, let's do that. Let's do that. So let's get rid of this here. We'll put it on LOD mesh. Sorry, I'm falling asleep. Do you around me? Good progress and crazy bug you found there. Yeah, have a good nap. Thanks for stopping by and saying hello. Sleep well, my friend. Sleep well. Okay, so we move that over. Let's put this as a my dynamic mesh. Yes, wonderful name. I know. And then I think I want to delete a lot of this out of here, actually. My throat this morning. Shambles, I tell you. Shambles. Yeah, I don't think I need any of this stuff anymore, because we're going to completely change spawning, and that's been commented out for quite some time. Not even relevant anymore. Although, yeah, I think I need to keep those just for... I think there's some other classes using these functions still. But I think I need to keep those around. Init LOD mesh. Okay, so this is where we're going to pass in some information about this mesh. And what information might that be? I would need level of detail. What do I need here? I need probably the terrain param, which I think would include the level of detail. Terrain gen params. Oh, I guess I don't know which LOD. indexes here. So let's pass that in. Then maybe we can get rid of the dependency on endless terrain. It's nice. Get LOD, add this index. Don't know what I'm going to use that LOD for. I should save the terrain gen params. Rather than the LOD. Okay. Probably save the LOD index as well. Okay, which means I should be able to get the information I need here, terrain gen params, which is really just get size, get grid size, get terrain chunk world size. That's what I want. Which is a float, I believe. Yeah. So that'll be this number there. Yeah, I guess I don't need the LOD index actually. I did before. Well, this maybe I'm going to put some more code in here now that I am going to use it. Okay, so this is a dynamic mesh actor. Which just has a built-in dynamic mesh on it. And I suppose I want to change the class of that. Do I need to do that with the object initializer? I feel like I do. Okay, Copilot, I didn't need that. Didn't need that. Don't you do like class or something? Set default subobject class. Is this a templated? Okay, so I think I put a name in there and then I can do like LOD mesh static class. Now I just need to figure out what. Probably just dynamic mesh component or something, right? Right there, Fred. Yep. Can't wait for that to get changed in an update and break my code here. That'll be great to figure out. Okay, let's make sure the settings are set here. I think we can. Let's actually do the static. They have these like render settings or something. What is it? What is it? Rendering draw path. You can actually do a static draw path, which is nice because these aren't going to change. You know, it's not like these are changing every frame. So we'll I think maybe a static shadow is okay. We'll see. We'll see. Maybe I need dynamic shadows. We do want to cast shadows. They enable false. We do want async cooking. We do want overlap events. Can affect navigation. Yes. Fill collision underneath for nav mesh. I don't know if I'm going to need that, because these terrain chunks are going to have caves and stuff. So I don't know how that's going to work yet with the overhangs and stuff. We'll see if we need that or not. For collision updates, that needs to be false in order for async cooking to work. I'm going to put a comment here for that. So that I know that. Complex collision, true, yes. Complex as simple, yes. Okay, so this all looks good. It's all like rendering stuff. That's just like a tick thing. It's all like collision related stuff. And then this is navigation stuff here. Get rid of LOD. Well, no, we're going to keep it there. I said I was going to keep it there. But I may move some code in here. Okay, so this should be being created by terrain chunk now. Dynamic mesh component. I'm setting the settings in here. Oh, I can set mesh draw path. Let's actually use that. Okay. So should I think maybe the mesh generator should live on the LOD mesh. Well, then that just makes it more difficult to use, usually. Because then I just gotta do one more step to get to the mesh generator. Alright, God, my throat. Not okay. Coffee helps that, right? Clean this up some more. I was trying to get rid of the dependency between endless terrain and like everything else. Which is what these terrain gen params are supposed to be for. And it did a pretty good job. Terrain chunk still needs a couple pieces of information from endless terrain, which is really, I should change the name of that. It's not endless. It's more like a terrain controller. And then let's refactor this. I want to rename this one. We're just going to rename everything. This is going to be dynamic. Well, I'm calling it an LOD mesh. I'm not actually using the LOD for anything. Dynamic chunk mesh. Sure. Sure. Okay, let's make sure that's initialized. And so when I get an terrain check, so when I get like dynamic mesh component, is that going to be my class? Probably not, right? Yeah, so I'd have to cast it. It's kind of annoying. I guess we can. What do I use world map for here? World map offset. Max world height. Okay. Okay. Yeah, I suppose we'll throw in a reference to the casted dynamic chunk mesh. Oh, and it's wrong function. There we go. Let's just do that right after we get the terrain. quick look at all our imports here. Get rid of anything? Yes, we can. Yeah, I can delete that code because I know, yeah, we don't need that. Don't need that. Render mesh, mesh done running, blah, 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 that's good. Blah, 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 blah. That should simplify function. Oh, I commented that out, didn't I? Yeah, let's turn that back on. I think I can get rid of that code. That's not an issue anymore. Shouldn't be. Boolean mesh. Yeah, I think that may still be necessary there. I'm creating a U object on a background thread, so I think I have to do that kind of stuff. Yeah, this calls back to the game thread anyway. So I guess we're just going to do that in the other class now. Like it's a little prettier. LOD. Okay, let's rebuild this real quick now that we've cleaned up. Let's actually run the real world test now. Not empty test level test. Okay. It hated that. Mesh generator, yeah, we can import that, I suppose. Hello, please, come on, writer. Please, I don't want to, dude, manually importing things is the absolute worst. Okay, thank you. Thank you. Okay, so wait, that's not the right... Not the right signature? Why is that not right? Why is that not right? Why don't you like that? Am I blind right now? Like, why is that, Oh, do you not have an object initializer for a component? Is that the issue? Okay, and this just doesn't even have a constructor in it. Base dynamic mesh component. Yeah, that one doesn't have one either. Okay, primitive component? Okay, there we go. Okay, so what are you doing? Wait, what are you doing? Stop that. Okay, so apparently I need this guy. Okay, we'll try that. And what does the other side of that look like? Okay, that looks to be the same as what I have. Set mesh draw path. Wait, I can't do that there. Was I not doing that in the other one? fine. We'll just we'll set it manually. Gross. Still? No overloaded function. Convert all the types. Did I not use the object initializer? Okay, well, I might as well, if that, I mean, I don't even necessarily need the dynamic mesh actor. Like, what does that give me? Not much, I don't think. It just kind of automatically creates a dynamic mesh component, so it's not like... What, see this one, oh, it's because it's on an actor. Okay. Wait, let me look. Am I being dumb? I just don't need this at all. I am dumb. I am dumb. I just don't even need that at all in this class. I only needed it on the terrain chunk to begin with. But let me look at dynamic mesh actor here. What do we actually... Oh, it has a mesh pool. That's kind of nice, I suppose. Although I'm pretty sure allocate compute mesh just like does new objects. Yeah, so it's not like it does a whole lot. Oh, I guess it's slightly different. I mean, it still does new mesh. So I have a dynamic mesh pool. Yeah, I'll be honest, I'm just not going to use that. I'm just not even going to use that class because it's not even giving me anything. So yeah, goodbye object initializer. We're not even going to use you anyway. And then dynamic chunk mesh. Default subobject U, dynamic chunk mesh. Dynamic chunk mesh, yes. Just make sure that's set to the root component. Let's actually change these to like get root component. Oh, I can't. Not on that one at least. This one? No, I can't. Okay. Never mind. Ignore me. It probably needs to be a like scene component or something. And root component is what? What is root component? Primitive? No, it is a scene component. So then it probably needs to be like something, some non-scene component class then to actually create the materials. That's okay though. Not a huge deal. Okay, dynamic mesh actor, no longer my friend. Oh, and then there's a function in here. I don't. Yeah, I can get rid of that. Okay. Okay. Can we build now? I don't even remember what I did in this pending commit here. I have a lot of changed files, I believe. Yeah, 34. Oh, I can delete the test character. Delete that, yeah. And that like actually deletes it, right? It doesn't like just remove it from the... Yeah, it does, okay. Okay, so let's run this in the real level, and actually we'll see the terrain generation happening. We'll see what the navigation mesh situation looks like there. Cool. We have built. Cool. Okay, I guess a quick test here, since we're here. Make sure it still works as we want. Oh, it's not. Okay, see, well, this is a good demonstration of the issue that was happening. Okay, so the bounds are no longer correct. Oh, and that's because it's not the same size. It's not the same, and it's not the same mesh component either. Okay, that's why. Yeah. So bad test now. I actually need it to be a ULOD mesh. So maybe we can change that real quick. Test dynamic mesh. Your dynamic mesh actor mesh needs to be... Wait, how can I change that? Here we go. Oh, this needs to be an LOD mesh, or a dynamic chunk mesh. Okay, and now it's broken. Now it's completely broken. Sick. Okay. Sick. Okay. Are the settings correct? Can ever affect navigation is true. Okay, what did I fuck up? Get navigation map. I have that. Terrain chunk size. I guess terrain gen params have not been set. So let me do the draw debug. There we go. Thank you. That's what I was looking for. Extent. Come on, you can do it. That's not the right thing. That's not it. What is it? It's like terrain chunk size, probably divided by 2, right? Oh, it needs to be like an F vector. Maybe box dot get size divided by 2. Okay, let's draw that box. It might be, I'm thinking it's like 0 or something. Because the terrain gen params aren't set up. Yeah, I'm not even seeing it. Okay, so let's do this. Probably need to change that function name. Not even blueprint callable. Okay. So yeah, let's rebuild this real quick after we make it blueprint callable and refactor it to actually be relevant. Can I actually get the right Shift F6? That is a horrible that's a horrible hotkey for rename. Init chunk mesh. Okay. Did y'all see that fucking Elon Musk like bought Twitter from himself for 45 billion or whatever, with money he made from VC funding XAI, his AI company? That is some Bernie Madoff shit right there. So fucking dumb, man. Just absolutely bailed himself out by taking money from investors from another company. Pocketed 1 billion on the way out too. That's nuts, man. Oh, to be rich and just, you know, be in the fucking back pocket of the government, be able to get away with whatever you want. That would be sick, man. I remember he tweeted back in the day, like, if he had what did he say? He could solve world hunger with $25 billion. That was the tweet, right? That was the tweet. Elon Musk world hunger tweet. Yeah. Show me that fucking. Where's the original tweet? I thought he had a world hunger tweet. Was I being gaslit? Okay, so he said, if WFP can describe exactly how 6 billion will solve world hunger, I will sell Tesla stock right now and do it. Where did I think that he said he could fix world hunger with 25 billion? That number is very, very specifically in my head for some reason. I mean, apparently it's even less than that, though. Apparently it's 6 billion. And honestly, I trust whatever, I don't even know what the WFP is, but I trust that organization more than whatever the hell Elon Musk tweets anyway. So 6 billion, could have done it. Now, buying Twitter, 45 billion, much more important. Much more important. Jay Blitzen, thank you for the follow, mate. Welcome in. Welcome to the the Elon rant. Get back to game dev. Okay, so still not working. That's fine. We need to initialize it. Init chunk. Init chunk. So wait, does this not... do I have to cast this? I do. Okay. Cast to chunk mesh. What? Wait, why am I blanking on... Oh, sequence, that's what it was. Okay, I was totally blanking on what that was called. Okay. This is the game I hate with blueprints. You gotta play this like game where you gotta line everything up right. Wait, don't I already have terrain gen params? Yeah, I do. I do. Okay, let's promote this to variable then. Make it all aligned perfectly. Sure, that looks good. Why not? Okay. Range in params, pop that in there. Where was the other one I needed? Right here. Cool, 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 cool. Okay. Are we good now? No, no we're not. No, we're not. Okay, and we're not even drawing the bounds. We're not even drawing that. Okay, yeah, we're not even hitting the code. Whoa, why? Are we hitting the navigation data? I am extending. See if we get here. Wait, what is happening now? Hello, please. Okay, we do happen to be a dynamic chunk mesh. Why all of a sudden is this not working now? Well, I know it's because I just refactored it, but why this isn't even the navigation is not even proper. Does it have collision? Hang on, let me go check. Sometimes the collision doesn't get like actually applied or something, which maybe what's happening here. Yep, no collision. Okay. Okay, Dick. Why? Complex collision. Use complex as simple. Let me look at the collision settings for it then, I guess. Oh, collision is just off. Dick. I guess let me set collision enabled in here. Where's the where's the function I'm thinking of? Oh, this is the function I'm thinking of. Oh, that took in a boolean. Does not. Query and physics. Okay, I apparently can't do that in there. What is the underlying field? Oh, it's on the body instance. Okay. Which there may not be one at that point. So I think I just need to change the settings on the component itself. Block all. Which, like, do I do that in the... Do I do that in here? No? Okay, maybe I need to do that in here then. Well, let's just see. Let's make sure this works first. Okay, now we're doing it. Now we're doing the thing. Yeah, okay, so... Okay, we got there, but still nothing's happening. Okay. Put those breakpoints back. What are my bounds? Terrain chunk size is 0. So yeah, that's not, that ain't no good. Okay, so that didn't even get initialized. Now it got initialized. And this is going to be much bigger than it actually is. I should adjust the terrain, right? Yeah, that's a sizable box. Let's make the lines persistent. Okay. Okay, yeah, I mean, this looks good. Now. Yeah, so the bounds are bigger than what it should be. That shouldn't matter. Oh dear. Oh dear. Oh, okay, it's just gonna draw forever. Yeah, maybe we shouldn't do persistent lines then. Okay, and then the terrain settings, scale should be 10. It should match whatever the scale of the component is. Okay, that's nice. Thank you for that. Still a little big, but that's okay. It's okay for testing. Okay, so do you have collision now? You have that to block all, so I should be able to run into you. No? Okay, I still cannot. You still don't have proper navigation, or collision, or navigation. Okay, collision type, use complex is simple. There we go, that was the answer. Okay, so it was just, wait, why wasn't that, we're using the dynamic chunk mesh, which is set to using complex is simple. Okay. I guess maybe the blueprint can override that, like these are just defaults. Okay. Okay, let's actually make sure all of the... Okay. Okay, it happened. It happened. Okay, so it works. The blueprint settings were bad. Okay, and it doesn't rebuild everything. Okay, sick. The bounds weren't right, but that's because it's a scaled down version of what I will be using. Okay, so let's move over. Stylized level with bio. We probably need a new name. What am I doing here? What was I doing here? Kindle mesh done generating. Querying that dynamic mesh. So I can't do this from, I thought this was happening from the game thread. No? That one's the game thread. Oh, I guess this one isn't. Okay, that might be the issue then. Okay, the world is building. Okay, is this happening on the game thread now? A little hitchy. No, where is the navigation? Okay, it's set to no collision. Okay. Oh no, and this thing is happening. It's the, is it the dynamic mesh? The dynamic chunk mesh body setup. Why are you async? Buxy wuxy, huh? Okay, so we need to set collision enabled on chunk. And I can't do that. Yeah, okay, I guess I just can't do that in the constructor. A little bit annoying. And so are we creating, we shouldn't be creating the dynamic chunk mesh on a background thread. So I'm not sure why it would be marked as async. We're drawing the bounds. I guess we'll get to see if those are correct. That one happened a lot faster, 8 seconds. There we go. There's my navigation. Look at that. Oh, it's beautiful. Okay. Okay, and the bounds are a bit big. Oh, it should be half. It should be half the size that it is. Yeah, it is marked as async. The dynamic chunk mesh body, the body setup is marked as async. Okay, so I think I can just manually fix that myself. Whenever we set the mesh from the mesh generator. But it needs to be... It needs to be where? Here. Clear flags. I wonder if I can clear flags on the component and it'll work for the body setup. Probably not, but if that works, then that's a lot cleaner. So we'll try that first. Okay, I guess we're just gonna rebuild. We're just gonna rebuild. Oh, and I needed to change this. Live coding on that real quick. Rickmatek, hello. Or Mikmatek, hello. Welcome. We are currently just cleaning up some of the fixes that we've done for the nav mesh generation here for our dynamic procedural terrain. And ensuring everything works still. Okay. There we go. It seems to actually be generating faster now too. Because the, I think maybe because the... Okay, now our bounds are correct. Now the bounds are correct. I just want to verify if I move one in here. Yeah, that's only generating where it needs to. Okay, let's see if is there any noise under here. There is a little bit here. But how did that work? So it did. We did get. Okay, so I have the. Let me ensure that this setting is the case. The what was it, like fill navigation underneath or something? Yeah, okay, so that is off and it's still putting some navigation under here. Now I think maybe the bounds are not they don't go down all. That is tentatively looking okay. This doesn't have any like overhang, so that one's probably fine. Okay, let's go to the. I want to go to my. Okay, and the body setup got cleared of its async status, so we no longer had that GC issue. Cool. Neat. About to test some things too. Well, good luck with your test. My tests are going swimmingly, and I hope the same for yours. Seed 17 I know is a really good seed. This has like really high mountain, so that was like a very flat terrain, generated very fast. This one's a little bit beefier. So we have the other one generated in like 8 seconds. This is 14, about 15 seconds here. Didn't exactly spawn me in a good spot either. It is generating navigation under here. Perfect. Perfect. Look at that guy. Nice. Nice. Okay, let me increase the nav mesh bounds, because that's not even close to what it will need to be. Not even close to what it will need to be. Okay, this should be like... what is 1 by 1? What is the scale there? Is it like 10 unit Unreal units or something? Or is that 100? That might be 100. Right? Let me just click play here. Okay. Can I color that in? How do I... Is it the brush component visible? How do I render this in-game? I want to see where it is now. Okay, I guess I can't. Okay. Where's my guy at? Okay, we're just casually being ragdolled. That's cool. Okay, and this is no longer... The terrain is no longer blocking visibility. So I need to make sure those collision settings are correct. Okay, so let's do some math for nav mesh size. I know I have 128 by 128 chunks. So each chunk is going to be, it's at a 50 scale, 240 verts. 128, and well, I know each one size is 12,000. So that is the... So divide that by 2. That is the number I need, I think. Well, no, maybe I think I need to divide by 10 as well, because or divide by 100 maybe. Divide by 100, what does that look like? 7, is that... Is that what I need? Doesn't like commas. That's kind of annoying. Yeah, that's a big boy. That is a big boy. And height, let's just make height 50. Nav mesh bounds are too large. Limiting requested tiles. Increase the tile number hard limit. Where is... Hey, where's the recast nav mesh? Oh, there it is. I'm done. Tile number hard limit. Okay, so is that good now? Yeah, I don't know if that's going to be high enough. Okay, let's run. It's a big nav mesh. We'll see what kind of issues we run into with that size of a nav mesh. Oh boy. Yeah, that is, it does not like that. It does not like that, does it? Okay, I didn't know increasing the size would reduce the performance that much. Is that just because of... Oh, it's just because of the display. Quick trace here. Oh, it's literally just like slate tick time. Okay, I think we're good. Nav rendering component. Yeah. It was just the rendering of the nav mesh. No bueno. Okay. That's fine though. That is fine though. Show it. Show me. Oh, you just stopped generating altogether. Why? Why did you do that? Oh, no, you didn't. You were just, not, updated. Okay. Dude, that is so cool how it figured out how to fill in some of this noise. That's so cool. I love that. Oh, I love that that's just working. Nice. It is putting the nav mesh inside this 3D noise. That is so cool. That is awesome. Very happy that that's working. Now the height needs to be much taller. 50 is not going to cut it. And I wish I could actually see that. I guess I need like a, I should probably come up with a min and max height. Because right now there is no min and max. It's just forever. Collision presets. Okay, so it's not blocking visibility, so I do need to update that. Oh, wait, that's the wrong thing. I meant to look at a terrain chunk. Collision presets. Okay, that is still also the case. Not blocking visibility. It should block visibility. Okay, so we can't do that either, I suppose. Might as well do camera as well. Why not? Okay. Wait a second. What is happening here? That's not right. Yeah, no wonder this doesn't look correct under here. Okay. We got some more work to do with the height map splitting that we're doing. And then I think the height needs to go up to like 200 or something crazy. Okay, so that's regenerating. Okay, we're getting some nav mesh up here. Cool, cool. Okay, it's not as fast as it was. Not as fast as it was when we had the small bounds. Okay, so I guess in a real okay, so I guess it cuts off before the peaks of the mountains here, but I think this is good enough for a nav mesh for right now. Yeah. Oh, that nav mesh goes deep. Now I should probably set up like the nav link stuff as well, especially for the bumpy terrain, because that is not going to be yeah, not necessarily going to be smooth. That's so crazy that works. Oh, I love that. Okay, so another thing I want to test. Can I even get out of here? Can I get out of this crater? Let's test that, I suppose. Okay, so I guess that fulfilled my test, which was I just wanted to make sure that new chunks that got generated are getting updated, and didn't update the whole thing. Okay, we're generating now. Yeah, so we're generating up here. These ones just got rendered. Okay, so we should be finishing up here momentarily. Okay, so I hate that it's actually generating on these right here, because that's not actually... That is not actually where it should be generating. And that is going to be an issue. Because what I'm planning on doing is serializing this nav mesh, so that it doesn't have to do this every time I load them. Okay. Oh boy, what am I going to do about that? Oh, I'm wondering if this, yeah, I've already been kind of thinking that this combining, I have a 2D height map with 3D noise, and I'm kind of combining them. And that's requiring me to do some kind of hacky things to get these chunks generated properly to connect these two different types of noise together. And one of the side effects of that is that I have these solid chunks, right? Like this doesn't have anything in it, right? Like this should just be empty. And I should only be, if I wanted the nav mesh to work properly, I would only generate the surfaces and not like the interiors, right? Is it? Oh yeah, it's generating on all the interiors. Yeah. Like it should only be there and not there. So I wonder what pathfinding would be like on this terrain here. Let me test, actually. I want to test, can I get my terrain deformation to work here? Hello, please? No, I can't. Okay. I know, it's a horrible animation. The horrible animation. There we go. Okay. And it did regenerate. I can feel it. It did try to regenerate. Cool. Okay, so it does have to regenerate the whole chunk's worth of collision. I mean, it did happen pretty. If I don't have the, I bet I can't even feel it if I don't have the render turned on. No, literally instantly. So I didn't even see a frame drop or anything. God, I hate this animation so much. Yeah. Yeah, so that's seems rather complicated. I mean, the nav mesh is kind of doing everything for me. Unless you're talking about the combining the noises together. That is complicated. And I was reading a bit how Minecraft does their terrain generation, and they primarily just use marching cubes, and then they have, in order to create the height map for it, they have a height bias, which was a new concept for me. Because, like, what you don't want is, what you don't want for, like, surface terrain is something that looks like this, right? Like, this isn't very navigable. This is rough terrain, right? And you wouldn't just want this blobby, you know, weird-looking terrain just on the surface. And so for me, that's why I use the height map. And so it does create, like, a more uniform, no overhangs type of terrain, and then I'm combining them together to create interesting like little caves and stuff, you know? But I'm wondering now if I should just ditch the height map altogether and then try to do a Marching Cubes 3D noise with a height map, or not height map, with a height bias to it. Or essentially you would be lowering the, you'd be subtracting the noise value. Because with marching cubes, you have they call it the ISO level, which is really just the threshold, right? You say anything below this, solid ground, anything above this, empty space. And then the algorithm just kind of takes care of it from there. And so the height bias would be as the altitude that we're generating at increases, so does our noise level. So we have more empty space the higher we go until you get to, you know, maybe some absolute threshold where, you know, nothing even generates. But that would mean then that I would have floating stuff, floating bits, which it's gonna be weird. It's gonna be weird. You know, for Minecraft that works. But I don't know that I can have too much of that for my game. And it's actually really nice the way I have it set up now, because I have height map noise and I have 3D noise, and it's really nice to just be able to know where the height map is. I know where the surface is, and I just have that all bundled up in a nice tight array. And I can like literally ask at any position in the world where the surface is, and I can get that very efficiently. So it's nice to be able to have that. It's nice to be able to have that. And I was hoping that that was going to come in handy with PCG, which, by the way, let's see what that looks like on this level. I was hoping that that would help me render, you know, decide where to spawn things. I can have height map surfaces and non-height map surfaces, you know. Okay, that did not generate anything. I think it's because my collision settings are bad. I think it's because the... Let me actually... I need to make sure that the nav mesh... take that up to 200 is what I set it to. Holy shit. There's a lot of tiles in that nav mesh. A lot of tiles. What did I had it, where was I setting the collision profile? Was it in here? Okay, yeah. Okay, so I just set it to terrain. Cool. Okay, so I think that should fix the PCG generation. But yeah, I was kind of hoping to just be able to pass the height map to PCG and just like spawn things on that. Because now it's gonna kind of be like there's no, if I do the Minecraft style of doing things, there's gonna be no method to the madness when it comes to these arrays of noise values. Because the height map, because it's 2D, I have, it's in a 1D array, but they have XY coordinates kind of baked into the indices of that array. So I can just, at any XY position, I can ask, what is the height at this position? And I can do that in constant time. If I just do entirely marching cubes, that's going to be a bit of an issue. I'm no longer going to have that ability. And I think I would have to resort to like hit traces and stuff. It's going to be less performant. And you can see not all of the terrain is generated. So what am I going to do for those areas? Then that, I mean, that did generate quite fast. That covered the entire area quite fast. That was nice. Okay, can we render trees and stuff now? No. What's even happening? The BCG is broken. Do I have the right collision settings on here now? Okay, it is set to block all. It's still set to world static. Let me check the... Okay, it does have to be on the collision channel. Okay. Why didn't that work here? It does have to be on the terrain channel. And from the git diff, that's what I was doing before and it was working. Although I guess I set it before I enabled collision. Ah, there it is. It's collision object type. That's the one I'm missing. Okay. Okay, now it should work. And I was kind of thinking about how the world is going to work in this rendered and unrendered state. And I was hoping to get to a place to turn off that debug trace now. I was hoping to get to a place where I could just ask the algorithm, what is this? Oh. Okay, I need an FGC scope here. Okay. I should probably create a function for creating and releasing U objects asynchronously. Because I've run into that before. But yeah, I was hoping to get to a place where I can just ask the algorithm for what is the surface at this XY. And that would be in a compute shader. And it would respond to me with it. But that was actually better and easier to use on the CPU. Stuck it initialize in Python again. Dang it. It was actually easier on the CPU because I didn't have to wait for the rendering frames to catch up. And it's kind of a wait. Like, yeah, the GPU is very fast, but it's kind of a waste if I'm only doing 1 point worth of noise. So it's like, might as well just do the collision. But that's the stuff that like takes up memory and stuff. So I literally cannot have the whole world generate. Just can't. Oh, I spawned on top this time because the collision channel was correct. Whoa. Whoa. Long way down. Yeah, it generates fast enough. Now, when PCG runs, it's going to have to regenerate. And that's kind of the problem, right? Like, I wonder if I should have custom navigable geometry exported, which is like a little, it's like a nav, there's the nav relevance interface on every component, and you can tell it, rather than to use just the collision data, to just use custom data, which maybe I could rig that up in a way that works better for me. And that way I can also run these PCG graphs before that, you know, when a chunk generates, run the graph on it, and then that way when the number, you know, and then we generate the nav mesh based off that. Well, how the fuck would that work? So I have this whole like PCG serialization system. Let's actually run that. That like I built it to like actually serialize the points to disk. And that way I don't have to rerun these graphs whenever chunks load in and out, because I'll already have calculated it. I already know what spawned there. There we go. There's some PCG stuff. That was quite quick. So it doesn't, is it just not going below 0? Look at that. That's so cute. Might not be high enough either. Okay, so this happens to be Meadows BIOS. So no trees. But the... Oh, did we not do collision on there? Or, did we not do, I just want the rock. Large plains boulder. What's your collision? It is block all dynamic. So yeah, that should have had... These should have, nav generated. Let me take this and move it just slightly. Now it did. Okay, interesting. Okay, so I may need to manually rebuild the nav mesh too. Oh my god, and it's actually spawning in the areas I don't want it to spawn in. Yeah, man, the cube thing I tried out, while it does make the noise look good, it is not working with the other systems. It is cool to see the side profile of it, though. Like, that looks kind of neat, doesn't it? Look at that rock just spawned right there on the edge. But yeah, like, there's some things that shouldn't be here. That shouldn't be there. No. Nor should any of that. Yeah. Oh boy. Yeah, I'm not sure what I should do about this. I do think I need to change the algorithm. What is that? Fuck. Yeah, it's not looking too hot, is it? A lot of rough edges here. A lot of rough edges here. Okay, so do I need to go back and rewrite the algorithm now? I was already considering it and being like, yeah, maybe I should do that. Maybe I should try it out and see how that works, you know. But I wasn't planning on doing that yet because I've already been working on the terrain so much lately. I wanted to move forward to other stuff. But now it's kind of seeming more important because of the way it's interacting with PCG and the nav mesh. They kind of... Everything's kind of based off of the terrain and how the terrain system works. Okay, I gotta run to the bathroom, but I'm probably gonna get some more coffee as well. So I'm gonna be right back, and then we'll try to break this stuff down. See if we can get an answer. Okay. I'm back with coffee. And fresh brain. And so yeah, what should I do about this this terrain conundrum? Well, I think the first thing I should do, because we're in a stable place, we should commit this. We should commit this code. Yeah, oh, okay, I added the terrain gen params in this commit too. Okay, so refactor to terrain gen params to split apart dependencies, fix nav mesh, the terrain chunk nav mesh issues. Okay. Okay. So we've committed that. Now we got a fresh, nice fresh slate here. Yeah, I wanted to get into, after this, you know, changing PCG a little bit to work better for it. But I'm a little worried now that it's not going to work properly. I mean, I do still just have the height map, and so what I was planning to do was, for PCG, you have this this combo right here, the world hit ray query and the surface sampler. Now let me pop a surface sampler down here. You can pass a bunch of things in here as a surface, and I was planning on making kind of like writing my own surface node and copying like copying the C++ class for this world ray hit query and changing it to like a terrain chunk query. Because right now, this is all my PCG spawning is dependent on collision, as we just saw. To spawn. So I have these terrain chunks generating around the player. The player's going to move. Chunks are going to generate in front of them and disappear behind him. And I built this whole ECS system, this entity system, such that I don't actually have to render actors for every NPC. None of them are actors, actually. They're instant static mesh components when they're rendered, vertex animated, and when they're not even in view, they're just in memory. Because I wanted the whole world. There's the whole world. We're only rendering like about this much, right, around the player right now. But the world's very big, and I want things to still simulate around the world. But I need them to generate first before they can. So I'm trying to think about, like, you know, if I don't actually have to build the mesh to actually walk around on, it's actually very, very cheap to generate all this stuff. I only have one render thread, but let me rerun this real quick, and we can take a little quick peek at what it looks like when it's generating, and what we have on the render thread going on. And I'll move around a little bit after I spawn to get some to spawn at runtime. Because right now I'm like, I don't queue up the compute shaders at all. Oh no, and we're borked here. This is another issue. So every once in a while I get this like condition where we're just stuck on one, like not spawning. And we may need to rebuild that. RIP. Yeah, I think it has to do with my height map generator code. How I use the delegates here. Maybe we can close this guy. And this one. Yeah, because you can have multiple... I need the height map before I can generate any chunk in that Z layer, because they're all dependent on the height map. And so I have multiple things like adding delegates to like lists and stuff, and I think, you know, whenever it finishes generating, I clear that list of delegates. So I'm wondering, there's probably something weird happening there because, you know, it's all async as well, so. But yeah, whenever I first generate the world, like before the player respawn, I just run all the shaders as I can. And so that's potentially multiple per render frame. But when the world is spawned, I switch to only doing one per frame. To make sure it's smooth when running around the world. And that's been working nicely so far. Let's try that again. That happens. Yeah, there's just some of the geometry script operations are a little non-determinate, which is an issue as well, which I think maybe the marching cubes algorithm, if I did it entirely there, would be better. Okay. Let's see if we can get some to generate at runtime. Kind of in a bad spot here. This would be a horrible start position. Oh no. Oh no. Well, we are generating some. Oh, I just went straight through the world. Cool, cool, cool. Okay, well that's a good test. Generating a bunch. Yeah, let's take a look at that. So you can see all this red up here. This is when I'm first generating them. I think this was probably the nav renderer before I turned that off. Now here's where they start generating at runtime. I think probably this was one. Oh, that's just some deferred rendering there. Yeah, like these little blips, I think. Yeah, there's one right there. 3D noise gen, 1.3 milliseconds. And then what do we have here? That's just a rendering thing. Doesn't have anything to do with my compute shader. Yeah, the worst ones have nothing to do with the compute shader. There's another one right there. 7 milliseconds for that 3D noise. Yeah, the world tick. 25 milliseconds there. I wonder if that was just because my character was moving so goddamn fast. Yeah, but for the most part, it can... I've gotten it to a point where it doesn't need to wait on the rendering thread too much. Because I essentially have 2 rendering frames to get a compute shader done and rendering done before the game thread will have to wait for it. And this is just plain editor, so probably a little bit faster than this in a standalone. But I went from like a slow algorithm that ran on the CPU that I could multi-thread to hell to a really fast algorithm on the GPU, but now I only have 1 thread to run that stuff on. So kind of a trade-off. I mean, the speed, like a world that I just rendered, took like 14 milliseconds before I spawned in. It used to take like 45 to a minute, 45 to 60 seconds. And that was only height map. That was no 3D noise. That was no marching cubes. So, I mean, the speed differential is just pretty, it's drastic. And very worth. But I guess the CPU one was really nice because I could just query the algorithm with a single point and I could get the height at that point. I could get Like, I essentially can know the terrain surface without actually generating the entire chunk, which is what I was planning to do for like PCG and stuff like that. Yeah, so now I'm wondering, PCG can run HLSL code now, but it's like free text, right? It's like yeah, like you just throw it in there, right? And I have mine in Unreal Shader files, so I'll probably just create my own PCG node, my own surface sampler. I mean, it would probably be nice. I should probably try and make the PCG grid line up with my terrain chunk grid. It's also only a 2D grid. And the thing is, the PCG grid is actually kind of opinionated. It does not line up at all. It is actually, the corner is at 0, 0. It is uncentered, whereas mine are centered. And I don't think that there's any settings to just be able to change that on the PCG stuff. This is runtime, hierarchical, partitioned. Yeah, I'm not seeing anything that would actually help. Before I forget. Comment that out. Don't need those anymore. Yeah. So, I mean, I think the easier thing would be for me to change my grid system to match up with PCG. And the PCG chunks are a lot bigger. I should probably do 128 to match up, because that my chunks are about 12,000, so that's close enough, right? 128. Okay, so and I do have splines for each zone, which define biomes and stuff. So I was planning to switch to those, because right now this kind of generates this biome core generates biome cell, like these biome cells, and they're square. And they essentially end where my chunks end, and where my chunks transition from biome to biome, even though like my borders can go through a chunk. They don't line up. They're not like perfectly square board. And so I was going to change this to just spawning within a spline, because I'm pretty sure you can do a spline stuff here. Spline sampler, create surface from spline. There you go. That would have been perfect. And so now what do I have to do, right? Like, let's say if I had the height map, I could have baked the height map into there as well. But we're thinking about a world where I don't have a height map, and I'm just running PCG, or not PCG, marching cubes. I feel like I need some way to tell whether or not a particular point on a marching cubes set of noise is underground or not. And I think the naive approach would just be like, for a given xy, check every z above it to find any solid space noise. And then you have to think about, okay, what about if there's chunks spawned above it, right? Like that could be the case. You'd have to check adjacent chunks as well. And what if you have empty space noise that is literally larger than a chunk? So, I mean, you literally have to check. I mean, and this is, again, the naive approach. You'd have to check every single chunk and cell, which is just not realistic. So the naive approach would not be realistic to do. Now, I suppose you could come up with a little data structure for each chunk, for each xy. Is there solid space at this xy in any z, at any z point? Maybe I should get paint out for this. And so that would be like a I'm thinking like it would probably, you could store it as like a 2D array of just ones and zeros, where the indices represent the xy. And it would just be like 0, 1, you know, fucking, you know, 1 would be like, yeah, there's solid space somewhere in this chunk, somewhere in the z direction. And draw a 3D cube here. Okay, look at that beautiful 3D cube there. So like you'd say like for this point, is there any solid space, right? And you could have like a blob of solid space, or yeah, solid space here maybe, you know. And so it'd be like for this point, like yes, there is, you know, put a 1 there at that xy. And you'd only need to do 1 layer, right? But you would have to walk through. I mean, you could just come up with it as the algorithm is generating, so you wouldn't have to like iterate more than you needed to. And so the big O time complexity would be the same. Like you could come up with this array in the shader. Let me pull up the marching cube shader here that I wrote. Marching cubes. Yeah, I could get rid of this fucking nastiness too. Oh, I went through so much. To get this working the way it's currently working, and I'm just gonna get rid of it. Oh no. Oh no. But yeah, for out vertices, I could have like an out height map or something, right? I could effectively come up with a height map, right? And so each chunk would have like this 2D array. You know, whatever this array looks like. Maybe it's just 1D, because I can translate the 1D coordinates to 2D pretty easily. So, you know, that's an array. Don't question that. So I would have to check the chunks in each direction as well. If I'm asking at a particular xy, where's the height map here? Where's the surface? I would have to check. Like, I don't need to iterate over every single point in the chunk, but I do need to iterate over every chunk in that z direction, right? To ask it, okay, what is your, you know, 0, 1 value for if there's surface in this chunk, right? And then whatever the max, it would be like max, it'd be the chunk in the max z, right? And I guess you could have some early outs, right? For if you find one, you could do like a, you know, start at this Z, march, you know, go to the next Z up and down. As soon as you find one in the down direction, you don't need to check the down direction anymore because you're just looking for the highest one. If you find one above, you can also stop in the Z. So it's like the first Z you find, you stop transversing in the down direction. And I guess you could have an even easier, another out for like another early out for if just the chunk is entirely empty. You could just have a Boolean for that, right? Another constant time operation, just like, hey, if this is completely empty above me, you could stop looking for the Z translation as well, or the Z surface as well. And it's like, how far do you search, right? Because you would have to have these chunks generated. I guess that's why Minecraft, because like I was surprised to find out. Let me open up the Minecraft like wiki thing that I found. Where is that at? Kept this open. So like they generate like the entire Z. Was it in here? No, it might have been it might have been in here. In this video.
Business taxes was always so.
Oh, taxes. Oh, I need to do mine this weekend. Okay, where is there we go. There's the picture. So they generate one chunk and they generate the entire Z, which was strange to me. But I guess I get now why that's the case. Maybe a little bit. I don't know. They probably don't. How do they tell what's the surface and what's not? Maybe I should watch that video a little closer. I did watch this video. Why don't I remember?
Take a noise like that, sampling it over there, right, gives us a value from -1 to 1, and then doing something to it. So, world now as opposed to before. That's a good start. Just need to be careful so I don't fall off the edge.
So he just explicitly
set a
surface
decoration and then make the world a bit bigger, then yeah, I can run around here. It is a bit boring. It's very flat, but it is a procedurally generated world. Okay. We want random terrain height, so let's randomize that surface y, right? So surface y equals 100, which is our base height, plus a random number from 0.
Oh, they just generate the surface y up front. Okay, maybe. I mean, this is like the naive
now what?
Algorithm here, so we'll see if that changes.
Oh yeah, as I mentioned before, simplified
Warning,
code.
greatly simplified code. Yeah.
But yeah, this is what we get. Kind of a mess, right? That's because every single block has a random height, so there's no continuity. But there is a surface now, and it is procedural, random. Okay, so we need to step up our game here a little bit. This is not really ending up where we want it. How do we get smooth terrain? So looking into the world of math, what is there that's smooth? Well, there's this thing, right, called a site.
So I guess actually I'm remembering now. So I guess they generate a height map as well. They use Perlin noise or some noise similar to it as well. But they just sample that in the marching cubes algorithm. Or whatever their equivalent is. Yeah, I was doing it. Maybe I should do that. I think I guess the problem that I'm going to encounter if I do that, because like what I'm doing now is I generate 2D noise, I generate 3D noise, and then I just try to like connect them together, which is really hacky and wonky. Because I want like the 3D noise to kind of like punch out the sections of the height map that it's at, and so I end up having to like stitch together these vertices and these triangles, and it just ends up really messy. And that's why like some of my chunks look very wonky on the edges and stuff. But I guess they probably just have something in here like Like here's where I'm sampling the noise and lerping between them, or connecting the edges of the cube. And I guess I would just say, like, if I would just return the ISO level if above height map, or -1 or 1, whichever. I forget which one I did for solid space and empty space, but I would return the empty space noise value if above height map Z, which is Y to them. But the side effect of that would then be that my height map isn't smooth. It would be very steppy. It would be very steppy. Is there an easy way for me to refactor this just to see what that would look like? Because I think I would need... The good thing about doing it the way I'm doing it is that the height map is very smooth, because it's not clamped to that plus or minus Z value. Which at the... we'll run this again and just take a peek here. So like here are all the triangles and stuff, right? So here's... Looking at this is probably... Let's go unlit so we can see it a bit better. So you can kind of see these are equidistant, right? In the Z direction. And so my height map would, I think, would be kind of stuck to that. Wait, no, because I'm lerping though. I'm lerping. I'm doing the lerp here. So I think actually the noise value, right, so noise value A, noise value B. I would actually, I would have to replace noise A, noise B, offset A and B. Okay, so actually, if I just overrode this noise A and B, either one, if it's above the height map, actually it could be smooth. Okay. Okay. I think I'm getting somewhere with this, actually. Now, my height map algorithm... Man, I can't believe I'm rewriting this again. Oh, I hate myself. Why do I do this? I'm actually doing it, aren't I? Fuck. I think I can keep the same height map. Okay. I think I could keep the same height map generation. Because in the height map that's how I'm blending between all the different neighbor noises as well. And I'm generating border mountains, and we're doing height curves and all that good stuff. So if I didn't have this, that would be kind of an issue as to how that would work. Okay, this is let me update my titles. We're now doing it's no longer morning. All right, well, no, it's still morning. But we are doing we're back to doing procedural terrain, which is what I've been fucking doing for the past month. UE5, I'm just calling it procedural terrain. That's what we're doing. Okay. So I guess now what I'm wondering is how he intersects the 3D noise with it.
Couldn't figure it out.
Oh god.
I was trying everything, but then looked like she had a stomach ache again the next.
That's so dramatic. Why was that so dramatic?
All right. So let's do it. I can go around here and go like, wow, this is so cool. But then after a while, I'll be like, it's kind of looking the same still, though. It's random, but it's
the early days of Minecraft.
A little bit up, a little bit down. You know.
I remember
So
Minecraft Alpha.
Like, where is?
Okay, I was
where
there.
Is the drama? Right? We get to part 2. Adding a terrain. So let's do more deliberate noise transformation. We're going to take our noise, our perlite noise, and I'm going to call it something. I'm going to call it continentalness. I could call it, Uncle Bob. It doesn't matter. But we use that as a mental metaphor for what it's supposed to mean, right? And we'll get more to that later. So we give the noise a name. And everywhere in the world has a value for continentalness. So as I'm running around, I can see that value change, right, in this flat world. And now shaping really means creating an indirect connection between continentalness and terrain height by putting dots on the graph. So in this case, I'll start very simple and say that, let's say that continentalness -1.
So this would be like the equivalent of my height curve multiplier.
And then I add a second dot over here saying that continentalness of 1 also maps to terrain height
that takes the noise value and translates it into terrain height.
Okay, and this is our spline.
And I did that before I knew how Minecraft to do. So I'm very proud of that.
And this gives us what? A boring flat world.
Yeah.
The Perlin noise varies quite smoothly. Cool. Now it's interesting, right? The Perlin noise varies quite smoothly, but the terrain height doesn't. It has jumps.
Yeah, you can do some really cool
stuff
stuff with the terrain curves.
And when you add a bit of surface decoration, yeah, you start getting a lot more interesting terrain, right? A lot more variation, just by moving the dots around. So we decided to do this on steroids. We add 3 noises here. So continentalness, erosion, and something we call peaks and valleys.
I read about this, yeah.
And we configure them differently. So as you see, erosion changes quite slowly. This one tends to generate ridges. We just configured it in that way. And this one tends to generate, they're just a little different. And they represent different things in the world. So as I run around, I see values for all 3 noises, right? And you can actually, as a player, if you play on the Java edition of the game, you play in single player, you can press F3, and you can see this pile of debug nonsense. And if you dig into that, here, multi-noise, C stands for continentalness, E stands for erosion, that stands for peaks and valleys. So you can kind of see basically these numbers as you run around the world, and you can see what it does to the terrain. So that gives us very interesting terrain, like plateaus like this, river valleys, or big mountain ranges, because we basically create a lot of these spline points. So this is the actual code, pretty much, what we configured. We're saying that continentalness, when it's low, this is supposed to represent
kind of
how far
inland. Do they only have one height curve?
That's the mental model, right? High continentalness is we're far inland. Low continentalness means we're kind of offshore. So that's why as we are low here, offshore, terrain height goes
Because for me, I have one of these for each biome. Like each biome, it has its own noise. Like I can do Voronoi, I can do all these different noise shapes, and they can affect the heights differently, which I think is really cool. And I think probably kind of what I have, like one step above Minecraft, which is, I think it'll be really cool. I need to play around with it more and get more going, but I think it'll be really fucking cool. But they can do a lot with just one.
Way down below sea level, and that's how we get oceans. So this single thing.
Yeah, it's the same way I get oceans. I have one. This would be like 0
and here we
right
get kind of the coastline coming in, and then as we go further up the scale, we suddenly get plateaus, and here it smooths out. But these points lead to other splines too. So we're saying that when continentalness is over here, terrain height is there, but only if the
I can't see where it's pointing.
Because then we have other splines connected to it. So we're saying that, but if erosion, let's say, is low, then guess what? Boom, terrain height gets even higher. If erosion is high, terrain height gets lower. And same thing there. Each dot here is connected to yet another one over here, saying that
and I have some additional curves as well for like altitude.
This is super complicated to explain.
Each chunk has an altitude value.
A while ago, it's kind of mind-bending. But when you sit with it, you move the dots around, look what happens in the world. It becomes clear for a little while until you go to lunch, then you forget it all again. Right? But it's interesting.
True.
The main thing though is that you don't need to write tons of code to change the terrain. You can move these dots around. Which also makes it kind of mod friendly. People outside Mojang can.
So wait, high Perlin value, high continentalness, low erosion, steep mountain ridges.
Tinker with these numbers. You can do that. You can make a cool world, right? by changing these numbers. So. Yeah, this is an example. This area in the world has high peaks and valleys. So we see
peaks and valleys,
peaks here,
not Perlin
It has high continentalness. We're far inland. This is a lake actually, and we have low erosion, which generally creates more mountainous regions. So that together causes these steep mountain ridges. This area of the world has high erosion, which means it's going to be kind of flat no matter what else. So all this is done via spline points. It creates an enormous amount of variation. So here we see an example of a lake, a mountain range here, so flat area. We want to cater to all playstyles. Some players want to build a castle on a mountain. Others just want a flat area to be able to run their horses on. Right? Others want to have lots of rivers to explore the world through. So the idea is that if you don't like what you see, just keep traveling, because you're almost certainly going to find something that you like after a while, because there's just almost infinite variation in there. Okay, so these 3 noises kind of together generate, this is like a map of the world, and as you can see, a lot of variation. These are high mountains, rivers, coastlines, deep ocean, things like that. Yeah, move the dots around, changes the terrain. You can also mess things up quite easily. This actually happened.
That looks pretty sick. I'd play in that world.
Then, oops, maybe we shouldn't ship this version. I don't know. I still don't remember exactly how it happened, but of course, what I'm showing now is just the base terrain shape. And the interesting bit, of course, happens when you add the biomes, right? So biomes are kind of like the paint on the surface to make the world really interesting. These are fjords. I worked on fjords. Has anybody read Hitchhiker's Guide to the Galaxy? I did not win a prize for the fjords. I'm very disappointed. I wish I won a prize for the fjords. But it was a very, very Hitchhiker Guide moment at that time. Okay, so I've kind of
3D
oversimplified
noise.
things
Okay,
a
this
little
is
bit
what
for
I
you,
was looking to get into.
because
Because like in Minecraft, before, they had an update where they went from like every underground being the same. Because like he was just talking about surface decoration. So obviously with their height map, they have the surface there then. And I guess I can still do it as well. I just need to change my algorithm a bit. I think I can do it. But they had this they called it like, you know, caves and the caves update or something like that. And then they had like cave biomes now, which I'm interested to learn how they did. Because what I was planning on doing was let me turn this back off for a sec here. So what I was planning on doing was like I wanted to have like volumes that were procedurally spawned or procedurally come up with some noise. I wanted to be able to make like a 3D volume, like not like a because like the volumes we usually use in Unreal are like the square ones, right? I wanted like a very 3D one, and I was hoping to be able to, you know, either I just kind of like randomly pick in the world where those are, or maybe I can procedurally figure them out and kind of clamp them to a particular 3D noise empty area that's below the height map. And then I can kind of spawn different things, right? Like maybe there's some bugs underground in this area, and there's like a whole bug colony. Maybe there's the dwarves living in the mountain, you know. If it's above sea level, you know, and underground, then, you know, high chance for dwarf spawnage. So very curious to see how they do the 3D noise, like cave biome.
All the stuff I showed you so far is just to generate the high level surface, like roughly where's the terrain right now, down here or up there, right? So kind of low fidelity.
Let me check the volume on this guy real
generate
quick.
the high level surface, like roughly where's the terrain right now, down here or up there, right? So kind of low fidelity.
Let me check the volume on this guy. Okay, sounds good.
Terrain height changes. The actual details are controlled by something else, which is called 3D noise. And I considered not including this because it's kind of hard to explain, but I'm going to try. If you don't get it, don't feel stupid. It is kind of hard to explain in like 3 minutes, but I'll try. 3D noise. Okay, so what you're seeing here is really the result of 3D noise.
There's 20 more minutes in this presentation.
And the reason why we need it is because of this. You can't get this kind of crazy of 3 minutes, but I'll try. 3D noise. Okay, so what you're seeing here is really the result of 3D noise layered on top of the terrain shaping. And the reason why we need it is because of this. You can't get this kind of crazy Minecraft terrain using just Perlin noise. Here we have overhangs and all kinds of weirdness happening. And this is what Minecraft is kind of famous for. This kind of total, you know, wackiness that can happen, and we really want to keep it. So how does 3D noise generate this? Well, 3D noise, 3 inputs, 1 output. So the inputs are the coordinate of the world, right? And the output is a value, and we call that value density, just a mental model for what it's supposed to be. So imagine that this is all the positions in the world, and each position has a value, and pretend this is 3D, okay? So every position has a density value, and all we care about is whether it's positive or negative. So it gradually changes as we in different parts of the world, but there's a threshold when it goes from positive to negative. And we basically define that level. Anything that is 0 or negative is going to be air, and everything that's positive is going to be stone. That's why we use the term density, right? Negative density, there's nothing there, so it's air. Positive density, there's something there, let's put stone, right? It has no implication in the gameplay itself, it's just a world generation kind of technique. But when we create a world using just this algorithm, we get this. I did a side slice of the world. You get a world that is just stone and air, and all the air parts here was where density happened to be negative. And because it's a Perlin noise giving us these values...
I think this is where the height bias is going to come in.
Okay, why are we doing this? Well, it looks cool. Maybe that's a good enough reason. But we then apply a bias to it. Yeah. So the higher up we are, the more we lower the density value. And the lower down we are, the more we increase the density values. We do an adjustment to it. And that pretty much squashes it a little bit. So it pretty much says that up here, it's mostly air, down here is mostly stone, and here's the place where density actually would make a difference, right? So why do we do that? Well, that's how we generated the actual terrain, the detailed surface of the world, because terrain shape is controlled by 2 things, squashing factor and height offset. Squashing factor is what I just showed you. This is an example of high squashing factor, where that bias is very strong.
I love that name, squashing factor.
World. But as we relax that bias, right, we reduce squashing factor, then the 3D noise is allowed to be shown, right? So I'm reducing squashing factor now.
And so are they combining this with the 2D noise that he was just talking about, or is he only doing 3D noise? I guess that's the point I'm missing here, because this is only showing the 3D noise. So is the squashing factor how much the 3D noise is allowed to show through the 2D noise, or are we out of 2D noise city entirely?
The lower squashing factor means more madness, right? And the other value, height offset, is just literally moving everything up or down, right?
Yeah,
Those
I have
two
one of those
numbers,
too.
Just those two numbers have a
It's so
radical-
crazy the amount of things that I've come up with that are like the same as what
effect on the
Minecraft has
world.
been doing.
So that's how
Probably
we
should have
kinda
looked at
spice
this a
up the
lot
world.
sooner, and I wouldn't have had to
In practice,
rewrite my
we figure that the
algorithms
same
so
way
many
using
times.
splines. So we define how continentalness and all these other noises, we basically add points for squashing factor, and we add points for terrain elevation, just like everything else. So those things together give us a mix of madness and kind of more normal-looking terrain. And I guess kind of this is where the mix between realism and fantasy comes into play, right? 3D noise kind of gives a fantasy element. Well, the terrain shaping gives us more kind of realism to it. And we want to be inspired by realism, but not limited by it.
I like that quote.
Okay, so a bit about cave generation then.
We want to be inspired by realism, not constrained by it. It's cool.
These are the new bigger caves we made.
Oh, dude, those stalactites are
they're
awesome.
generated essentially using 3D noise as well. So I'm going to talk a bit about that. Aquifer, these underground water was a whole separate chapter that would take about half a day to explain. It was so freaking difficult. But
Oh,
really glad
man.
it's over.
Oh, I want that video. Give me that video. God damn it, Wix,
It's
get
not
out of here.
crafty. It's your craft.
But, okay, noise field. This is a noise field. Imagine that, let's just do a 2D version of the world, just to understand this better, right? We want to make caves in a 2D version of the world. Here's a noise field, 2D noise, and of course, white and black is the Perlin noise output. Let's just decide that white is air and black is stone, similar to what I showed you before, right? We decide that white is air, black is stone. If we do that, and apply that to this little 2D world, then we get a cave system, right? We get, well, not a cave system, independent, not connected to chambers here in this case, right?
They call it
That's really
cheese caves.
Cave generation is easier than the other stuff. We call these cheese caves.
And that's what I
because
have
they kind
now.
of look like Swiss cheese when you look at that map. And they tend to generate these big chambers, and kind of, yeah, big chambers in the caves. However, we notice that we do a little bit of transformation to make it a little flatter, to make it possible to run around. There's some tweaking we do, but basically it's that. That's the base. So we call them cheese caves because they looked a bit like cheese, and then the name stuck, and yeah, the rest is history. But what we didn't get from this was long tunnels. So to get long tunnels, after a lot of experimentation, and I want to emphasize that everything I'm showing you here, none of it was obvious to anyone. We had to do a lot of head banging to really find it. So it's really easy to underestimate how hard it is to change the core of a game in this way. So it's kind of risky and stressful, but I'm glad it worked out really well. But anyway, in this case, we have another noise field, and we defined that the border between black and white, that's going to be air. So we kind of take another approach now. So that's white, that's black. Here is exactly that shade of gray. It's going to be air. And the rest is going to be stone. If we do that, we essentially get
I see.
spaghetti.
I have a noise setting for that I was planning to use for, I was going to call them noodle caves or Perlin worms, but they're not actually Perlin worms. Let me look up that material real quick. Yeah, I was going to use something like this. Here was my noise that I came up with to do. And what I was going to do is actually stretch it horizontally. Because, like, obviously I don't want tunnels that just go straight down. You know, maybe some of those are okay, but I want them mostly sideways to be able to walk around on. So I was going to take this noise. This is essentially, I think, probably something very similar to what he's talking about. I was going to stretch it. So we'll see what he does.
Like long, winding tunnels. It's a little different in 3D. There's a little more we have to do for 3D, but I don't have time to explain that. But the basic principle is the same.
I think he's probably talking about what I just did,
This
where
is
you have to
called,
like stretch it or
noise
something.
ridging. Because, yeah, we can go back to the algorithm there. It's really just take the absolute value of the noise, and if it's less than a certain constant, then it's cave. Right? So yeah, that's these so-called spaghetti caves. We have a thin version of them that we call noodle caves.
Oh. Cool.
And what's cool is when we combine these things, that's when the magic happens, right? You take these caverns, and you take these long tunnels, and you mix them all up, and you get incredibly interesting and varied cave systems. You can just keep exploring. Even as a developer, when I run around inside the caves, I just keep getting surprised, even though I spent so much time like working with it. So it's really interesting how much variation you can get when you have enough variables that are kind of interplaying. Okay, last bit. Biomes.
Yep.
If we
Cave
have time.
biomes. Okay.
I think we do. Right? So Minecraft world is divided into biomes, right? So here we have a jungle, and then over there we have some plains or savanna. And as I mentioned before, think of it kind of like a thin layer on top of the terrain. So for example, that would be the jungle. Or in the jungle we have jungle trees and a lot of grass and stuff, and desert, a lot of sand, right? So biomes control things like what's the surface material, what's the color of the water, and also things like what structures show up there, right? In deserts you can find desert temples. In cold areas you can find igloos. So it has a pretty big impact on gameplay experience. And I'll give an example of the same location. Now I made the whole world just desert. So everything's desert. Now it's the exact same terrain shape, but meadows instead. Now there's a village that decided to show up for some reason. Exact same location, grove, And here you see by the interplay of the cave generation and the terrain generation. When the caves poke out, you get cave entrances. It's interesting. Badlands, which is very characteristic. And then here's a swamp. You normally won't see swamps up in the mountains, but hey, I made a swamp world, so this is what we got. And jungle. So yeah, biomes have a big impact on gameplay. So how do we place them? Right? How do we decide what biome to place where?
I have an entire biome map
talk a bit
that I
about
use.
that.
Essentially a biome noise.
5 noises. So we have these 3 noises already mentioned, and then we have 2 more, which we use for biome placement. So temperature and humidity. It doesn't actually mean temperature. Minecraft doesn't have heat. You're not gonna like start sweating when you go there. It's just a kind of a metaphor. And the combination of those values decide which biome. So now we have 5 numbers here, and they're all changing as you move around. And depending on what those numbers say, we hit certain thresholds, and it goes boom, no more Badlands. Now we want savanna because it got more humid, I guess, or maybe it got a little cooler. I don't remember, but one of these things hit a threshold. So these we configure using tables because biomes are discrete. You're either in desert or plains. You can't be kind of in both. So it's discrete, and therefore we don't use splines. We use tables.
Interesting. Okay, let me read this. Because my biomes don't have like any rhyme or reason really. Like I just have I'll show it real quick. Where's my guy at? So here's my biome map. And then this is like the world map, right? And then I come up with I do Voronoi noise here. And then I assign a random color to each Voronoi cell. And then that ends up connecting the cells together in an interesting way. And then I just, those colors represent the biome that's there. And so what I was planning to do with this is once I get, because like, you know, right now just being constrained to like a color being a biome, but actually the more biomes I get, the less interesting it would be, the shapes of the biomes themselves, because it would mean less would connect. And it, like, I wouldn't get this shape up here, right? They would all probably just look like this one right here, this yellow one. Which not very interesting, right? So I was planning once I got more biomes to do like a second pass over this. Once they're all connected in an interesting way, then do another pass and assign them biomes. And I wonder if I could have like a different set of noise for like temperature and humidity to kind of influence that a little bit, to influence the RNG. So I think I would just pick them by RNG, by a deterministic RNG. I think is how I would rather do that. Because I think with what he's saying, with like he was saying, like the when the number changes, like the value, each cell has a value, each Minecraft block has a value for temperature and humidity. And when that changes, then a new biome starts. So that kind of seems like he would all have the same temperature and humidity biomes next to each other. And like with what I'm saying, that would be the case as well, but it would be a little bit more random because all I would use it for is influencing. I would just weight those biomes more heavily. And hopefully I would do that in a way where, like, yeah, obviously the snow biome isn't right next to the desert biome. But yeah, that's what I have. And then each one of these has a different terrain noise set of parameters as well. That's why I have to blend between each of the neighboring noises for the height map. So yeah, mine's already quite different.
So this shows the table. If we're in an area where peak noise is high, then we look at continentalness and erosion, and that decides which biome we're in. To make this easier to configure, we split the noise values into number ranges. So we said that you know, erosion 0 means a value from -1 to -0.78, right? Erosion 6 means 0.55 to 1, just to be able to reason about it. So that's what this 0 means here. It's that number range. And then we basically say that, okay, let's say this place I'm in right now is far inland, and quite like it has a high continentalness value, and it has low erosion. So then this basically lookup table says, all right, there's going to be a peak here. Okay, but what kind of peak? There's different types of peaks. Well, that depends on temperature. So in this case, high continentalness, low erosion, low temperature means jagged peaks. It's these snowy things. Right? And this is independent of terrain shaping, or semi-independent. We've configured them to somewhat match. So when the biome is going to be a mountainous biome, terrain shaping is configured to generate mountainous terrain. but they're not hard coupled. It's more like a soft coupling via the configuration. But anyway, so we travel a bit, and here we come across a jungle. So how did we decide that that's going to be a jungle? Well, in this case, we were low continentalness and medium erosion, so this is going to be a middle biome. And what the heck is a middle biome? So we look at that table,
Oh, God.
and that table says, well, okay, it's a middle biome, huh? And humidity is high, and temperature is kind of high, so it's wet, kind of hot. Okay, let's put a jungle there. Right. So we could have called these noises noise A, noise B, noise C. But using these words like humidity and temperature, it just makes it easier for us humans to actually understand what the heck we're talking about when we're configuring this stuff in the code.
Sunflower
But
plains,
it is a metaphor,
interesting.
and it's not a perfect metaphor. Like, for example, it says wet here, and yet there's a desert. Doesn't quite make sense. But we're not optimizing 100% for realism. We're mainly optimizing for, in this case, having deserts be rather big. Right? But this gives us a lot of flexibility. So yeah, here's our jungle. So these 5 noises together generate, in this case,
That's a cool map.
this is a map of the biomes in the world. Right? You see that there's a lot of interesting variation. Cold area here, hot area with badlands and desert. There's a coastal region with some beaches, or there's a massive swamp. It gives each part of the world its own characteristic. Oh, here we
Maybe
got
that's
big
it
beaches.
here. Yeah, that's a cool map.
It gives each part of the world its own characteristic. Oh, here we go, big beaches. Configuring this is tricky because you need to understand what you need to think. You need to visualize a 5-dimensional grid. What's hard about it? Why does it matter? Because neighbors matter a lot. We don't want a desert to neighbor, for example,
They do,
snowy peaks.
and that's
it just looks
difficult.
ridiculous. So when we configure these tables, we think a lot about what biomes could neighbor which biomes. But it's a 5-dimensional configuration space, so each cell has 10 neighbors, which makes it really hard. What's interesting is after a while, when you sit and work with this, your head gets warped enough so you start seeing things in as a 5-dimensional grid, and you get brain damaged. So for a while, I was a bit brain damaged. I could be outside looking at a slope there and seeing numbers in my head. Luckily, I think I've recovered from that now, feeling less messed up. But yeah, this kind of thing, I drew this. If you stare at it long enough, you either understand or you go insane. One of those 2 things happen. No guarantees offered. Okay, wrap up. As I mentioned, there are no takeaways. It's up to you what your takeaways are. This is just me sharing.
The way
what I
he
thought
didn't
things were
talk
interesting
about
terrain
cave
generation.
biome.
But I guess if anything, it's if you play Minecraft, it might be fun to
Damn.
think about, like, hey, now I know why there's a mountain there. Or if you have kids or friends who play Minecraft, you can show off and say, oh yeah, I can see that. Must be a low erosion area over here that you're in. They're like, what? I don't know. But also maybe you work in other areas. Maybe you work in game development or other areas where some of these techniques might be useful. Most of the stuff I talked about here is not unique to Minecraft. A lot of these techniques are quite commonly used in other games as well. So, but I just wanted to share what we've been doing and what we've been learning. So yeah, thanks a lot.
So I guess there's going to be some questions. Maybe there's some interesting questions back here.
So thank you very much. I think we have time for questions.
Miraculously, we do. Anybody have any questions?
Yeah. Okay, let's start close here.
Did you consider any other alternatives? I mean, like using machine learning or something like that?
So the question was, did we consider other alternatives such as machine learning? And yes, we did a lot of exploration at the beginning of this update. One big consideration is performance, since the world is generated on the fly. If we could pre-generate a world, our options would be much wider. But yeah, performance was probably the biggest thing that pushed us in this direction.
So a question you can...
Oh no, you saw the weirdness, did you? Darn it. Yeah, the weirdness is a noise too. Weirdness is a weird noise. It's a noise that is used to generate, let's say we have a jungle, but sometimes it's a bamboo jungle. Well, that's because weirdness was negative. So it creates variance. It's also used to generate, in some cases, weirdness is used as a noise that indirectly influences peaks and valleys. So when weirdness hits certain thresholds, you suddenly get a river or a peak. It's kind of weird, that's why it's called weirdness. We couldn't come up with a better term. But
Okay, cool.
yeah, good question. Good, nice job spotting it. Yeah.
In new update 1.18 here, you must have 3D biomes for the cave biome.
Yeah, 3D biomes is an interesting question. We had a lot of trouble trying to figure out what to do with that. Thing is, before Caves and Cliffs update, there were no cave biomes.
Right, okay, this is the juice I
biomes
needed.
were 2D. If you're in plains, it's going to be plains no matter how high or low you go. Now you might be in plains and you go into a cave and suddenly there's a lush cave down there, which is a different biome. So we struggled a lot with how to make that work in a consistent way. And we pretty much ended up with having all normal surface biomes be 2D. They go all the way from the top to the bottom of the world. And then we inject 3D biomes just for the caves. So saying that, okay, this 3D area is going to be dripstone caves. With
So when you say inject, elaborate, please, because that's what I need. Maybe he's talking about doing something similar to what I was doing, where you just kind of like, you have a different set of noise that is the 3D biome.
stalagmites and stalactites. But everything above and below is going to be plains. But that's been very tricky because initially we thought we would use 3D biomes for everything, but then we got really weird things where I'm building my house, and I'm placing some block.
And then you get to a high enough level where you leave like the plains biome, and then all of a sudden like placing dirt gets really weird or something.
And suddenly the grass color changes 10 blocks higher.
Yeah.
Why? Well, because there's a jungle in the sky, right? It's plains here, but there's a jungle in the sky, but I can't see it because it's just air. And we've got all these weird edge cases. We're kind of like, screw it. Biomes are 2D unless they're caves and they're 3D. It's a bit of a compromise. But the technology for it is there. So we might go back to making 3D biomes in the future once we figured out the design of it. Because it was really that we didn't have time to figure out the design implications of it. These are super cool questions, by the way. Yeah.
User interaction with the world, is there any math behind that, or is that just stored changes?
So if a user changes the world, right, what actually happens? Yeah, what actually happens in this particular, it's a little bit different on our different platforms, Java and Bedrock, but in the Java edition of the game, once you explore a part of the world, it generates that chunk and saves it. So generation is a one-time thing. And then every time you change a block, it just saves that. So the world is persistent in a sense. I think in Bedrock it's a little bit different, but yeah, it's a very interesting question. Because some other games don't do that, right? I'm sure some of you, how many work in game development? I'm just curious. Oh, wait, I thought Sweden was the mecca for game companies. Nobody works in game development here? Well, that's interesting. Wow, a few maybe. Anyway, but a pretty common thing is that you just throw the delta. So it's basically saying that Henrik added 8, dirt blocks here, and that's all it saves. And the next time you go there, it regenerates that chunk and applies that change. I'm not an expert on that kind of stuff. I can see advantages and disadvantages, but I would say probably mostly for historical reasons.
Yeah, less storage space if you do it that way, but then that means you have to regenerate it every time, which, for me at least, serializing is faster than generating. So I would rather have a larger storage size if it means that it's also just easier to save that way, right? Like just saving the delta and having to reapply that delta is a little difficult. The code is a lot more difficult to reason about. But yeah, I would rather just have a larger storage size and just be able to load back faster, right?
Minecraft stores the chunk permanently once you've generated it.
Yeah.
All the way up there.
Thank you.
I have 2 questions.
Yes.
The mineral generation, right? We redid that too, and there was a bit of controversy about that. That you changed the levels of coal and diamonds. Was that generated the same way?
Yeah, so the question was about ore generation, right? Because in Minecraft was called Minecraft.
Good question.
Mining, you find ores. And because we made the world bigger, I didn't mention that, but with this update, we made the world basically 50% higher and deeper.
Ooh.
So everything's bigger, which means we need to fill the world with something, right? What if I go dig deep? There needs to be something there. And it basically forced us to completely redo the balance of which ores generate where. And we took the opportunity to try to make that more interesting. But the way ores are placed, we actually didn't really change that. Like, basically at a high level, for each chunk, it randomly decides how many placements of iron are there going to be here based on the configuration. Let's say it decides that there's going to be 5 blobs of iron, and then it pretty much just rolls the dice. Okay, let's try to place one down here. Oh, I can't. There's air there. Okay, never mind. I'll try to place it over here. Ocean. Darn it, skip that. What about here?
So it's like a
here there's stone.
post-process
Let's shoot in some iron
type
ore.
thing.
So it's old tech, new configuration, pretty much.
Interesting. Okay, I don't know that I'm going to be able to do that for mine. At least I wouldn't know how. I need to take a look at my marching cubes algorithm here. How would I do that? Because I do want ore. I was thinking about just PCG spawning them, which I guess maybe is kind of similar to what he's talking about, but I think they do theirs at an algorithmic level for sure, because they need to decide what each block represents. I was just planning on like spawning them, collision intersecting, and then just like as you dig through the world, you'll just come across it, and you have to dig them out. That's kind of the naive way I was thinking about doing it. Which I suppose would still work, as long as it's a it would be kind of a deterministic thing, and I could do it per chunk. What would I want to do with that? I mean, I suppose I could have another set of noise. Jeez. You know, you could have a set of noise that you sample for if there should be ore at a particular vertex. But how would I represent that in the world? I suppose that could just be a material ID, right? Because the dynamic mesh has different material IDs. You could add that. I think I would have to do that after the Martian cubes algorithm happens. Yeah, I don't know how I would actually do that. Bruce Malt, what's going on, my dude? Saw you were doing some procedural stuff earlier today. I'm thinking about rewriting my algorithm once again. So here's what I got so far. Here's my world. You know, maybe you've seen this already, but it's gone through some updates. So here's the world. So yeah, it's not bad. It's not bad. I have 2D and 3D noise. It's a little wonky looking. And I'm now discovering or coming to terms with the fact that the way I'm doing it may not really work with my other systems very well. So yeah, this is what I got. And I'll go top to bottom and explain the whole process here. So here's the world map. And here's me. And so the world map initially generates, it's just a Voronoi noise. And then for each Voronoi cell, I assign it one of these random colors. And then it ends up kind of connecting all these cells into interesting shapes. And then each one of these is a different biome, or a different zone, rather. Right now, a zone and a biome are one and the same. So you can see some of the parameters that I have up there at the top. I've assigned them random LLM-generated names. Phantom Bloom Refuge. And this one, actually, that I'm in is aptly named Stormwatch Peaks, which actually matches up with what the hell's going on in the world. But yeah, so that kind of generates my zones. Each one of these zones gets assigned a random set of parameterized noise. And that noise ends up getting passed into my compute shaders, like my height map generator here. Here's some of the params, right? F noise params. So here's like the noise generation params. And these are copied from, I ended up having to copy them, but they're copied from this right here. I actually found the shader code for this and I copied it. So that's an example of like some of the noise. Oh, and I forgot to say, here's the world map where the water is and the darkness and lightness is generated from some noise put into a texture, right? So here's the world map and that matches up here. And that just gives me the altitude value for how high or low it should be, right? So altitude 0 right here, you can see that up at the top, ocean. And you can see it's kind of dark down here. So altitude is like 0.2, 0.9, or 0.09. And then up here where it's lighter, altitude is 1, like it's very high. And so I have, as a part of the noise parameters, I have curves. I have these, I have some of these curve values here. So here's the altitude multiplier curve, right? And so I take this and I multiply it by the altitude, and then that determines how much is this zone affected by altitude. And I have an offset as well that'll just move it up or down. And so you can see, I like this. This means that there's going to be like some flat, a little bit of flat territory up here, just to make it, you know, walkable and stuff like that. And that's probably, you can see like it's kind of flat once we get up here. So that's probably where that's at. So that's kind of like the world level generation. And then each one of these has, I can turn on PCG as well. This one isn't very interesting. I really only have 2 PCG biomes, but here's like where it spawns all the assets and stuff. And this just is my shitty meadows biome, right? I have a forest one as well that looks better, but those didn't, we didn't have a randomly assigned forest biome next to us. So this is what we got. This is what we got here. And then I also have like random materials as well. So like this would be like the red zone. We get into there. And this is a height map auto material. So once it gets lower, in the world, it starts generating the actual grassy areas over here, rather than the rocky dirt areas. And so I have a 2D noise and I have 3D noise. All of what I've talked about so far is all just 2D noise. And so that generates, a height map, as I'm sure you know, Bruce. And that 2D noise, I actually end up having to do a weighted average blend per chunk. And so what that ends up looking like in shader code is this monstrosity of a function where I have to get all 8 neighbors. And because you have to write code like non-dynamically, like you can't allocate new memory on it within a compute shader. So that's where I'm like, I have to get each indices noise like this. And it's really annoying. But anyways, I have a weighted average blend where I sample the noise for each neighbor chunk's noise parameters, which is what we were just looking at there. Like these are the noise parameters. Thankfully, ChatGPT loves to, or Copilot will just generate this for me for the most part. So that's really nice. A few years ago, that would have been very unfun. But here you can see I'm looping. There are 8 neighbors, right? So if you have a 2D chunk, there's 8 neighbors around it. And each, I think one thing I forgot to mention is each pixel on here, where's my guy at? Each pixel on here is a terrain chunk. So you can see as I hover over each one, that's where the values change. So like for this red one right here, I have a blue zone above it and a yellow zone to the right, blue on the left, right? And so that chunk, each vertex in that chunk is a weighted average blend between every surrounding chunk. And so I essentially just say, what would the noise be at this vertex if it was rendered with the neighbor chunk's noise parameters? And sometimes that's the same, but that just adds to the weighted blend. So we have the weight sum and stuff, and then we get the final value. So that's part of the blending. And once I got that done, ooh, was it just chef's kiss beautiful to see that? Because then you just get this, like, this is actually 2 different biomes right next to each other, right? Like I have the super high biome up here, and then I have like the super low biome over here, and it just happens to be by the high altitude. So this would actually be like, it's almost like kind of like a Badlandsy type biome where it's like, kind of smooth, but then we got some just bumps and ridges throughout, and it would actually be grass if it weren't right next to this one, I believe. So once and it's blending together smoothly, and it all connects, and so that's just beautiful. That's beautiful to see right there. Noodles, oh, don't get me started on noodles. So yeah, that's most of it, and I'll continue talking about it when he gets back. But yeah, I'm discovering that the way I'm rendering the meshes here, the way I'm putting them together is just going to fail for, it's not going to work correctly for things like navigation, right? So here's the nav mesh, and while it looks, I finally got it to generate properly on here, it's generating inside the chunks, right? Like I don't need that, and that's going to cause issues, right? Same for PCG. PCG is spawning in some of these where it shouldn't be, which is also an issue. Find some, there's some right there. So yeah, essentially what I do with the meshes is I kind of like, I create a height map. I just do the height map noise, which is non-overhang noise, and I just kind of extrude that down to where it should be. And then, if it's just a solid chunk and there's no height map in it, then I just generate a cube. And then I take the 3D noise, the 3D marching cubed noise, and then I just do a geometry script Boolean subtraction from it, which is just like the geometry script is a built-in function. And then it allows me to subtract the noise out of it. And we have some artifacts, right? Like there's the edge of a chunk. So it's a little rough around the edges. But there's no holes, which is I think the most important part. I should have shadows turned So I have the, I think static shadows turned on. Maybe I think I need to do dynamic shadows, because you can see there is a rock somewhere up there that is shadowing through. I think I need dynamic shadows. I thought I could get away with the static ones, but it doesn't surprise me that I couldn't. I think static draw is fine though. Yeah, you can see. Look at all the all the rocks are like shadowing through because they don't have the shadows turned on. He's back. Okay. So I was just saying that like the way I'm rendering the chunks, I'm coming to terms with the fact that it's not gonna work, right? So here's the nav mesh on top of this. And you can see like this chunk is just not rendered yet, this empty space here, and it's generating not only PCG on it, but the nav mesh, which is just not going to work. And the way I render these meshes is like I have the 2D height map noise, and then I just I kind of connect all those vertices together and the triangles together, and then I just extrude it down to where the chunk end would be. And then for, like a chunk that's like in here, right? This would just be like a solid cube essentially. So I extrude that down to where it should be. And then I do some slices at the top and bottom for if the height map exceeds the height of a chunk, right? Like there's one little peak up here. I got sliced off of that chunk. I just got really laggy for some reason. Let's turn off the navigation. There we go. And then the 3D noise, which is Marching Cubes algorithm noise, which is just it's just blobs, right? It's just a bunch of blobs essentially. What Minecraft calls cheese caves, I've now found out. I just take that noise, I connect that into its own mesh, and then I use Geometry Script, which is a built-in library in Unreal Engine, and then I can do a Boolean subtraction where I subtract the 3D noise mesh from my like height map cube, and then that's what gives me the overhangs and stuff. And you can see there's some artifacts from that process, right? Like this guy right here, like ain't supposed to be like that. The edges are a little bad, but I was okay with that. I was like, you know what? As long as there's no holes, because what I was doing before was I was actually trying to stitch together the two noises and like move. I like had this flat height map noise, flattish. Then I had the 3D noise, and I was trying to like intersect those together and stitch back together all the verts where they intersected, because you want the 3D noise to kind of punch through the 2D noise to create the caves, to show where the caves are and stuff like that. So, but that process, and you can see the verts and triangles here, that process created a bunch of holes in the mesh where you would essentially just fall through the world. So can't have that. So that's why I tried this like cube approach, which worked a lot better for reducing holes. But it also has its own downsides, and I'm seeing that now, which would be like this, right? Like that's not supposed to spawn here. In my PCG system, like I have this like serialization system because I have an ECS system for my entities, and when the entities move around the world, they need to be able to query these PCG points, whether or not they're loaded in the right. Like we're only generating a very small radius around the player, and the world is huge, so I need it to be able to query not only the serialized PCG points, but also the terrain as well. And the nav mesh I will be serializing, so that should I'll have to figure out how to do that, but that'll essentially not reload whenever a chunk goes in or out, right? So if I were to start walking, chunks would start disappearing, nav mesh would start rebuilding in those areas, but I want that to not happen. Anything else okay, yeah, the other thing I do is these white points, and it's kind of hard to see in this. Let's get a different seed. I can show it a little bit better. Do 19. Let's see what 19 looks like. What I want to talk about the border splines. And so for these zones on the world map. Okay, this is a good one. There's the border for this zone. And I guess these two zones happen to be the same sets of noise, it looks like. There's me, there's the nav mesh. Okay, so let's, I'm gonna face north here. Okay, so I'm in the cyan zone. It's actually a big zone. But you'll see that the mountains are matching up. You see there's the break right there for this little neck. But what I do is I build a spline for the edges of these biomes or zones, and then I use that to generate mountains. And so like for every vert in the height map noise, I have to calculate its distance to the nearest spline point, and then lerp. And I have a curve for that as well that I apply to smooth them. But then I lerp to create and increase the height there. So that's how the mountains are generated. And then the white points are what I call zone entrance chunks. And then that's where I would actually not have it affected by the spline. And so that's how you would get from like zone to zone. And you can kind of see some of them you can't go from one to another, and so you'll have to get creative as a player to get from one to the other. But you can see the blend is actually happening a little bit here. It's like this noise is a little bit different from this noise, and that's probably the altitude blending that's happening. And let's run around a little bit, see if we can get some new noise to generate. But that's basically the algorithm so far. Now, what I'm thinking about doing is just using the marching cubes algorithm to build the mesh, rather than doing all this geometry script stuff. I will still need the dynamic mesh component, but I will just be appending vertices. I won't be doing because what I do is like some Boolean subtraction, some mesh simplification, mesh fill holes, and that's kind of bad. It works very nicely, but like the bad part is that it's not deterministic. I found out, which is a problem. I'll see here we have some really tall mountains, and so this is like the entirety of kind of this section of the blue, this cyan zone. And I guess what I'm looking at, what am I looking at over here? So I guess I'm looking at the green zone. Oh no, it's the red zone, Sharp Mountains. They called this one the Burning Steps, which is a WoW zone name. That's an issue. we can't have direct rip-offs like that. And then I have the LLM quest generator as well that I'll use for like NPCs generating quests, and hopefully they'll be able to reference these zones and stuff like that. But yeah, so that it ends up creating some interesting. So here we can see the blending really well. And so this is let me actually run that direction a little bit to get some more generated. And I have it generating in a small radius just for like testing, so I can load the game up faster. So yeah, let me pull up the world map here. So yeah, so this red one is Sharp Mountains, which I guess is what they're not exactly mountains, are they? But that would be like the kind of Badlands-ish area I was talking about. Same noise. I only have like 4 different sets of noise, I think. So, but you can see how that gets blended across there's the zone entrance chunk. That would be like right here. It's probably this chunk. But you can see how that gets blended nice and smoothly. And you do see the lines from the where the chunk ends, and that's just that's a lighting thing. That's not an issue with the noise. It's an issue with the normals, because you have to like for each vert you need the neighboring verts to average the normals, and for these edge ones you don't have the next one over. You don't have the neighbor one. So the solution for that is to generate one more ring around each that you end up throwing out just to get the normals calculated properly. But I'm not too worried about that right now. So didn't quite get why you think you need a full rewrite. Yeah, well, maybe not a full rewrite. I just need to change, I think, the way that I'm doing it. And it was just because of the way the nav mesh and which, by the way, let's run PCG, see what we get here in these areas. Maybe we can get some forest. Nope, meadows again. Dude, is it all meadows? Did I break my forest? I might have broken the forest graph. But essentially, like, the way it's mainly the way I'm creating the meshes that's the problem. You'll see in here. So this is supposed to be solid space, right? So if I turn the nav mesh is generated in an area that it is never walkable because of how I put the meshes together. So like these areas are the only things that's actually supposed to be, you know, solid space. And I probably shouldn't be spawning grass in here or nav mesh because it's not reachable at this point. And so this is all, this is kind of why I'm thinking about redoing it. And then just letting the marching cubes connect everything. And so we were watching a little Minecraft video to see, kind of take some inspiration from how they did things, which is pretty cool. A lot of it I'm actually doing already. But you can see like the solid edges are an issue, right? And the artifacting that happens as well. This one actually doesn't look too bad. You can see like the edge of chunks kind of don't match up sometimes with the 3D noise. 2D noise looks great. But it's because of how I'm doing the mesh and everything, so. Yeah, that's it. That is it. So yeah, this inner area that actually doesn't necessarily need to be there. That's just there so that I could subtract out the noise properly. I need to come up with a way to get rid of that. And so I think what I can do is in my marching cubes algorithm, I think I can just override the noise, like the naive approach I think to this. Like Minecraft has like they do a height bias. And so based on where the height is in the world, they kind of modify their 3D noise values to maybe not be as solid the higher you go up, right? Because it's either solid or it's empty space. And so the higher you go up, the more empty space you have. That would create like how much the 3D noise is able to affect kind of the height map. Which I think what I'm planning to do here, I think I need to pass in my height map. Again, I had it at one point, but then I got rid of it. So I need to pass in the height map that gets generated. And then these noise values are, this is lerping between 2 points. So the marching cubes, like if you imagine a cube on its edges, each vert has a noise value for this cube. And then for each edge, you need to lerp between the two noise values to get to like where 0 would be. 0 is the threshold between empty space and solid space. And so that's what's happening in this function with this lerp here. And so I think I just need to, again, naive approach would be just to override one of these noise values if its vertex is above the height map, right? And then it would lerp to where the height map value is, I would hope. That's what I'm thinking of doing here. Let's do that. Let's do it. So I need to add, setting up these compute shaders is kind of a fucking pain, I'll be honest. Kind of a pain. Marchingcubes.h. Let's, here's our struct for what we pass in here. And so you can create read-write buffers that contain data, or you can have just read-only buffers. I kind of want it to be read-write, even though I don't plan on writing to it right now. And Bruce, I was seeing you actually, I was seeing your planets and stuff. You were, it almost looked like plate tectonics that you were dealing with. I wasn't there for too long, but it looked pretty cool. You were like little, you generated these textures or something. And you had different, you had the planet, but you had like different views for it. So it was looking really cool for, was it plate tectonics that I was seeing? And you said you looked into like, what did you say you looked into? Like the fluid stuff or something like that for like water? I don't know if I understood that correctly or not, but you're like, yeah, I looked into that last summer and no thanks, which I totally get. I did see, hang on, let me try to look this up. I saw this the other day. last night. Check this shit out. See the water like filling up the 3D space here? I was like, oh shit, dude, if I could use this. And they actually have a texture that gets updated, which is kind of cool. So I was like, damn, dude, if this works. This plugin just works, man. That would be pretty sick. Pretty sick. But that's a journey for a different day. Let's go ahead. I'm gonna duplicate this. We're gonna call this out height map, and that is going to be a buffer of just float, because its position in the buffer will represent the X and Y. The float will represent the height. And so let me open the shader library code here. Okay, execute 3D noise gen. Okay, so we are going to need a out noise. We are going to need the I'll call it out height map, although it's not going to be being modified yet. I have a feeling that I'm going to want to, because I think I'm going to want the 3D noise to influence the height map a little bit. So I may edit it in the shader. The gradient descent is doable and fine, so if you just want a nearly solid river, or what they're doing, relatively slowly filling up a space, that's not too bad. I have not looked into fluid simulation at all, so I have no idea what it takes. But like for me, I may want like pockets of water underground and stuff like that. And then of course when you like break that pocket, I want it to flow into other areas. So, knowing Unreal Engine, they probably make that very difficult. Parameter, did I do the wrong one? Oh, this is the 3D noise gen. I am in the wrong one. I am indeed in the wrong one. I need marching cues. Okay, so in noise, out vertices. Yeah, let's grab that. How am I doing in noise right there? It's a little bit out of order, but fine. Okay, so let's just copy this to out height map here. Okay, and that'll be a float. Okay, so now we've created the parameter for our shader. Let's actually add it. Size of... There we go. Okay. So that's all set up. Let's update the parameters here. Simulation isn't even that complicated. You basically have two matrices of values, one old, one new, and the new matrix is filled from the neighboring chunks. So very similar to how you're interpolating. Yeah, I guess it's the real-time nature that that throws me through a loop there. I definitely get that concept. But it's like, how are you updating that real time such that it's performant? Like, you'd have to do that every single frame, right? And you have like flow rate and, you know, viscosity or something. Just to make it look really good, you need a very fine matrix. Yeah, I guess so. I would worry about performance. And then also like the data size as well, because like I'm already, you know, taking up quite a bit of memory with all these chunk vertices. And if I have to have an even finer set of, you know, nested arrays or whatever, what have you, to store the fluid data in, then that's just gonna, you know, increase Increase the memory usage that I have. Okay, so I need to pass in I do have height map data here, so I do have the height map. I can probably just directly pass in. It is in a 1D float array. Perfect. And what did I do? Was that the first param? Yeah, okay. Height map, noise data. Oh, height map data. Oops. Okay, I'm not passing that in as a reference. Let's do that. Exactly, I just need some river. It doesn't need to be sub-second updates. Yeah, I don't know what I'll end up doing. I do want rivers and stuff, though. I think what I'll end up doing is turning some of my mountains, I'll just invert them and create river borders. But then maybe also have a world level pass when the world gets generated, create just some world rivers, and then maybe those can just naturally split up some biomes. But for the actual fluids, like, I don't know, like what I had before was just like a flat plane of water, and just like anything under that, underwater, right? Doesn't matter if it's inland or outland. It was like Valheim does it, which I'm not sure if you played it, but they just like, water level is water level. If you dig below that, water shows up, right? Why are you mad here? Why are you mad here? Oh, it's I'm passing it in by constant. Let's do ref here. I need that one to be rep. That's one approach to doing water. Yeah, I mean, hey, works for Valheim, and they have like water mechanics as well. So, not even like it's not even like it's janky. They do what they need to with it. Why are you mad at me? I literally have you implemented. What are you complaining about? Okay, you just weren't updating. Okay. Okay, so we're good there. We have the height map data being passed in. Now we actually got to create the bindings in here. So, duplicate this bad boy, float out height map. Okay, so now we have height map data in here. So now I gotta translate the vertices in here. So I need to get the height map value in my lerp function for each of these. So I'm gonna need like a, let's create a function for it. I'm gonna return a float, get height map value. And so we want, I guess this will be a vert, so it'll be int 3 or float 3. It'll be a float 3. Will be a vertex. And what coordinate space is this going to be in? What am I working with here? Red ID. So the thread ID represents the vert, and that's just in the minimized level of detail space. So at the settings I have right now, max verts per chunk is 240, and if that's in the centered space, it would be -120 to 120. But when it's in an array, you can't have negatives in an array, so it's going to be 0 to 240. But this is in the simplified space. So with the current LOD that it's at, would be 40, because that's it'd be 240 divided by 6. Yeah. So I'm at LOD 3. 3 times 2 is 6. I just multiply it by 2. We get 40. So red ID is going to be 0 to 41. And then offset, let me remember where I'm using this at. Offset, okay, right. And then we're just moving one vert in some arbitrary direction. And so the height map is stored in the same space. So that actually makes it very easy. So now I just need to int noise index. Is that actually right? Vert Z. I only want X and Y. It's a 2D. It's a 2D. I'll take that, but I need to get rid of. I only need X and Y. Right, so it'd be vert. I think it's this. What's the 1D to 2D? Y times X plus X. Is that it? Yeah, I think that's it. Or it's rather Y times size. The Y value times size, which is extent. Yeah. Plus X. Yeah. That's good. Okay, so then we have that int height map value. Yeah, and we can just return that. Perfect. Just return that directly. Okay, so now I can get the height map values for each of these. Vert A height map value. Give me Vert B copilot. Hello, please. There we go. Thank you. Okay, we have the height values, and we're gonna get rid of this. This is no longer friendship ended with that code. Now other new code, my friend. Vert A. So this is in the incremented centered space. That's fine. And so I need to transform these height map values into their world equivalent. Do I have the current chunk coordinate? I don't. That's an issue, because now I don't know the relation to the Z, because this could be a chunk that's way underground, and I don't actually know that, so I need to pass in the chunk as well. Okay. That's going to be an int3 chunk coordinate. So we need to pass that in. Go back here, int3. Oh, I am wait, what? I'm passing in a chunk coord here. What? Okay, I already have it. Am I actually passing that in? I deleted it from the shader. Okay. Hell yeah, passed me. Hell yeah. Execute. Oh, I'm never setting it either, or am I? I'm not. Okay, so we do still need to wire it up. It's just got to delete it out of the parameters, I guess. That's okay. That's okay. Chunk board. Chunk coordinates. Update that declaration. So that's passed in there, and we just gotta add it up in here, up in here, up in here. Wait a second. Am I using the wrong thing here? Oh, I'm not passing it in here. Okay, yeah, so that was a little oopsie fucksy there. Now, height map UAV. What was that? Uniform access view, I believe. Increment. I guess we'll just f int vector. Chord. Do a const ref. Why not? Update that one. Boom. Okay. So now we got to find this guy. Yeah. Do I have the chunk coord here? Am I passing in the chunk coord? I do have chunk world location. I do have chunk coordinates. F-vec. Okay, so that should be the 3D coordinates. Cool. Chunk coord. Why are you mad? Chunk coord is not an int vector. That's the problem. Okay. Can I just convert that? Is that an easy? Do we have an implicit conversion there? We do. Tick. Okay, that I believe is all wired up now. Okay, int3 chunk coordinates. And that is in just, 0, 0, 0, 1, negative 1, 0. That's in that space. So I do need to multiply that by the chunk size. Or rather, I need the unscaled chunk size. Which I think is just num vertices in the z direction times the increment. Which would be extent.z times increment. increment is 6, so it would be 40 times 6. Let me actually do the right fucking calculation there. Okay, 240. Okay. And so that is what space the height map value is in. Is it doesn't take into account the mesh scale, which is 50, because that just gets applied after we just multiply by 50 at the very end. So unscaled chunk size, I would need to multiply the z by that, right, to get the current vert. So I have vert A height map value, and then I'm also going to have vert A and B height. And that would be, yep, that. Perfect. No, not that actually. Vert A index.z, vert B index.z as well. Okay, so now we have, now these two can be compared to each other in the same space, if I'm right. Okay, let's get all this out of here for now. Okay, so essentially I want to override these noise A and B's. Ooh, I actually think I need to do this in the noise generation step. And then get noise for vert. Yeah, I need to do that here because this noise is dependent on the triangulation. Or rather, the triangulation is dependent on that noise as well. So I can't just do it in the save lerps. I have to do it. Okay. Moving the code. Where are we at? Right in here. So this actually, we're not going to do that either. Okay. So we have a vert, so we're only going to do this for one vert now. Vert height map value, vert height, vert.c. Let me make sure the right vert space is being passed in here. Get noise 1, vert x equals cell, noise 1, thread ID. Okay, boom, we're good. Okay, x10 z unskilled chunk size. That's still all good. Get height map value. We will need to move that function to above. We will need to move that. There we go. Okay, so if now to actually properly lerp this, I actually need to subtract these, right? 8 time. So I have, what do I have? Okay, here's a height map. Here's a height map, right? There's my height map. Let's say I'm considering a cube that is intersecting the height map, right? And so we're getting the noise for this vert, if I can actually point to it correctly. That vert, right? So this vert is above the height map. And let's say, okay, so negative below 0, or I'll say less than 0, air, greater than 0, we'll go greater than or equal to 0 is solid. Right, that's what we're saying here for this noise value. And so this may be solid, but we don't want it to be solid because it's above. Like this doesn't matter what these two are actually. But what we want is the lerp to give us this value right here. Which means like this, let's say this number, we can't just return the ISO level, which is 0, the threshold. So we can't just return, if we just returned 0 here, then that would, I think, if I'm thinking about this correctly, that would move the height map up there. Because I'm lerping to 0, wherever 0 is. So I think I need to take the distance differential here. And so if I have the vert height, I need, first of all, I need to do the check if vert height map value is less than vert height. I'm gonna write that backwards. If vert height is greater than vert height map value. So if the vertex is higher than the height map, then I think I would want to return vert height, because that is going to be the larger number, minus height map value. Let's say 0 is like right there. That's 0. And so let's call this let's call that that's going to be 10. And so let's make this like 12, which means the noise value here would be 2, or for this vert would be 2. I need to divide that. I need to divide that actually. So we need to put that back into unscaled space, or into the vertex space, right? So we would have something like, I don't even know what that would be, like, and that would be a, I would need that to be a negative number. So I think I would actually want to do the subtraction backwards, and we need a parentheses there anyway. I want that to be negative to create the empty space. So I'm going to subtract them the other way, because I know the vert height, because it's above height map value, it's going to be bigger. It's going to be a bigger number, more biggie. And then I need to put it back into the coordinate space, like the cell space, vert space. So let's say that's 2, or it would be -2. -2 divided by the unscaled chunk size, which is would be quite large, right? That'd be like 240. It'd be like -2 divided by 240. Yeah, so that would actually be a very barely 2 is actually a very small number there. When each cell actually, let's make this a more realistic set of numbers here. So I know each cell is going to be 50. Well, right now each cell in the simplified space is, what's the math for that? I'm going from 40 to 240. So it's 6. Each cell is 6 big. So 5 is actually a more realistic number there for the differential. So then it would be, what, 5 divided by 240? So it'd be -0.02, is that right? No, that's not right. I'm not thinking about that right. I do think that's the right math, though. Do I want to think about that harder, or do I just want to see what happens when I run it? I feel like that's right. The numbers I used in my example were just kind of small. Let's just see what happens when we do that, okay? Let's just see what happens. And so if, yeah, we're now no longer in this case, we're no longer paying attention to what the noise value naturally would be. And it explicitly has to be greater than. So would this wouldn't punch through the height map, actually. Right? Fuck it. Let's just see what happens when we run this. Right? So we're going to need to change quite a few things. Oh, this is in noise. This needs to be out height map. So that would have been a big issue there. Glad I saw that. Glad I saw that. See, I don't know if this is actually going to expose things underground. Maybe it will. Let's give it a run. We need to go into our mesh generator, and we need to not generate the height map anymore. So I think we can just comment that out. Our subtract, we just need to create a new set of functions. Like this is, it's all going to be wrong, okay? Let's just call this build terrain. Build terrain mesh, sure, sure. And I should have all the stuff I need. Height map data. Do I need that? No, because I just need the vertices and triangles, really. So we are going to copy some here. I need to, yeah, I need to do all that still. Because we need to get rid of all the triangles that didn't end up getting made. That's what this is doing. There's all the buffers. So now I can just append buffers to mesh. Oh my god, if this works, it's going to get so much cleaner. Oh, I hope this works. What? No, that's the wrong. Append buffers. Append buffers. And I'm doing it to the Boolean mesh. We're no longer going to do that. Now, I think I need to actually flip the triangulation as well. I think I need to flip the triangulation down here. Okay, let's see what happens. Oh, how I hope this just... Oh, if this works the first time, holy shit. Oh my god. It's not going to, so don't worry. Place your bets now, though. Okay, where would it go wrong? Where would it go wrong? I think I need to have a special case. I think I need to handle it specially. What is this? Execute 3D noise gen. Oh yeah, this is this is okay, we can just add a parameter. This is a test function, so it doesn't really matter. Out height map noise, just throw it in there. What? Oh, I need the chunk as well, right? Just throw an fn vector in there. Which parameter is it? Oh no, local position would be the chunk, right? This is 3D noise gen. Wait. You don't need that at all. That was an old to do. Okay. Was an old to do. Okay, so yeah, where would this go wrong? I think I need a special case for when there is already empty space below the height map. So I need to narrow it down to scenarios where a cell is intersecting, or the vert is like within a cell of the height map. And then I need to check one below. Be like, hey, if this is empty space and above is empty space, I don't need to do anything. I think maybe I need a... Well, do I? That may be baked into that already. I don't know. We'll see. So that there could be something wrong there with the 3D noise just not even showing up through the height map. The height map may not even get added. This may not even be... We may be in the wrong coordinate space here. We may have just absolutely... We may be getting the wrong height map value as well. That might be wrong. I don't think it is. I'm quite confident in that being right. Oh, I'm not doing the chunk. I added the chunk in here. I ended up doing nothing with it. That could be... I'm definitely not getting the right Z there either. So vert height needs to be... I need to add the chunk coordinate on here. That's one thing that... And look how fast shaders compile, like, compared to like live coding. Boom, done. Got compiled there. The nice thing about working with them, you do have to do all this kind of boilerplate to wire them up, but once you're just tinkering in here, quite fast to iterate. Okay, now what are we doing? Is that good? Do I just need to add the chunk coordinate? No, I need to do chunk coordinate times extent.z, actually. do I move it up times x? And then I need to center it. Times the extent. Yeah, I need to center it, so I need to subtract extent.z divided by 2. Jesus Christ, that's looking ugly. That's looking ugly. Yeah, so times extent.z, which would be 40. Front coordinate times 40. And I just need to subtract half to center it. Yeah, I think that's right, actually, now. Recompile. Okay, yeah, fuck it, let's run it. Alright, cross your fingers. Okay, yeah, we're not even getting the height map. So if you voted for that, if you voted for height map not even getting rendered, then you are correct. You are correct. You're probably wondering how I ended up in this situation. Ooh, neato. Neato. Well. Okay. What's yeah, here's the world. Pretty cool. Dude, there's enough space in here that you can see the atmospheric fog start to take effect. I need to change the sand texture to be like a dirt or rock texture. Yeah, the whole material space for this is going to be interesting as well. Okay, so yeah, we're not even getting the height. We're not getting the height map at all. I wish I could see what these values were. You can't debug. You can't put breakpoints in a compute shader. You have to get creative. Do I need to... I think I maybe need to do this, actually. Because the vert Z is uncentered as well. Chord times extent. This would be, what would this represent? Let's pop this out. It would be like chunk position, which we, I don't know if I like that. I don't know, because I need to subtract both. Trunk chord, which should be in trunk chord space. Let me make sure that the right one's being passed in here. Chord from terrain chunk. Yeah, that is the right one. So it's going to be like 0, 1, you know, negative 1. It's going to be like that. Getting the height map value. Let me, I'm going to throw a breakpoint, I guess. Let me just inspect some of the height map data. Sure. Throw it in there. And let me look at what some of those values are. Because it seemed like this maybe was never getting reached. And maybe I have this backwards. Let me try flipping this. Maybe I had it backwards. Maybe this is just entirely wrong. Okay, what's my height map looking like here? Okay, yeah, our values are pretty low. Okay. Just wanted a sample of that. Oh, look at this. This looks a lot better. Oh, look at that. Oh, shit. Okay, our mountains are gone. The mountains are gone. But we have noise and it's showing through. Oh shit. Oh, look at that. Okay, edge of a... Oh, it looks so good. Oh my god, look at that. Honey, get the camera. Oh, look at that little tiny... Just a little tiny hole. Wow, that was somewhat easy. Now I have to figure out why are my mountains not being included in here. This looks a lot better. Yeah, that seems pretty. Pretty pretty, I like that. You Germans and your play on words. Okay, yeah, that's the height map is completely flat. That's the issue, I think. So I don't think the height map value is in the right space. I'm always impressed when like non-native speakers can pick up on the like idioms and puns of a different language. Because like those are like inherently just difficult to understand because they don't really make a whole lot of sense. And I think pretty is one of those kind of things. But you Europeans came out of the womb speaking other languages, so maybe it's easier for you all. 4 languages do not make sense to me. I took 3 years of German. First year A, second year B, third year C. I was like, okay, I gotta stop. I'm not doing well. I'm getting worse. And I remember very little from it now. Anyways, height map stuff. Yeah, so the height map is completely flat here. So either we're not lerping properly, which is based off of the noise. Which is if the vertex height is greater than the vert height map value. And so chunk coordinate Z could be negative. If it's 0, it'll be 0, and then we're going to add the vert, and then we're going to subtract. We add the vert. I think actually we need to subtract the vert. So I believe it would start at the top, and then as it increases, it would go down. Yeah, I remember you were learning Klingon, which is kind of funny that the app has that. Entirely Klingon stream win. Not being in school and being graded on it helps a lot. Yeah, my friends and I were talking about that when we were in German. Like, we talked about like it would be fun to learn German, not like years later when we weren't in school anymore. Like, just for fun. Just to talk in German. Mein Schwanz ist sehr groß, ja. What do I need to do here? Oh, you can't speak it. Oh, what's the point? Oh, it has 10% of the words you would actually need to say what you want. And like Klingon itself, I mean, it's an alien language, so like you wouldn't expect that to actually have, you know, like the one-to-one relationship to our language, right? Like I like that moment in Game of Thrones where in the beginning where Daenerys is like, what's the Dothraki word for thank you? He's like, there is no word for it in Dothraki. Yeah, I think there'd be a lot of that in Klingon. Yeah, so I need to do something with this height map value differently. The vert height map value. I shouldn't need to do anything to this one. What if I didn't divide it here? What would it look like then? Okay, still completely flat. Even worse actually now, because it's I think below where it needs to be. Okay. Unscaled chunk size. Extent times increment. Maybe just divide by increment? I'm just guessing and checking now at this point. I'm not actually thinking. Thinking is hard. No, that still doesn't. That still look bad. Das war sehr böse. Oh no. Oh no. Okay, we gotta rebuild. Okay, so unscaled actually looked the most. It didn't seem like... It didn't seem like the verts were in the right space, though, still. Times unscaled chunk size. Maybe just times increment here. Times increment and divide by increment? No, I think I need... I don't know. We'll see what that looks like. I don't think that's right, though. Close all these. Oh, I didn't rebuild the shaders. Hang on. Still flat. Still flat. There's no Klingon word or idiom for hello. No greetings. I actually kind of like that. No pleasantries. Cut out the fluff. I hope there's no small talk in Klingon either. How do you say how's the weather? I would prefer that. Yeah, I needed to build those shaders. Yeah. Oh, that looks better. There it is, dude! There it is, dude! Okay, it is a little steppy. It is a little steppy, isn't it? Bit more steppy than it was. Oh, bro, I can't believe I just... Dude, the amount of time I worked on the other fucking solutions, the 2 other times that I refactored this, I spent so much goddamn time, and then I just do it in like a fucking hour today? Like, are you kidding me? I mean, I'm happy. I'm very happy. A little upset at my past self for not thinking about this, though. A little upset. The edges are quite sharp, but that's... You know, I'll settle for that. I will settle for that. This oh, and there's 0 artifacts because it's all done. Ugh. Oh, and what was my generated time? Probably a bit faster, right? 12 seconds, 14 seconds. Still about the same time, actually, which is kind of interesting. I mean, that's not... I mean, looking at it from this, you can tell, like, it's a little marching cubed, but, oh god, that is kind of bad, isn't it? I wonder if the lerp isn't correct. I wonder if we're a little bit off still. Yeah, this looks a little bad. This looks a little bad. And what is that? Why is there a nipple here? Get rid of that. Ah. Come on, come on. I don't know why, like, it's so hard to get this collision to work correctly. He's cold. Yeah. The landscape, this is a very low, Come on, why isn't the... Dude, I literally, I had this sword. I don't know why this is so... Okay, we're ignoring that. Ignoring the nipple. I wanted to put a hole in it. Can I try it right here? There it is. See, look, that worked right there. And it actually, like, rebuilt the collision and stuff. That's really cool, right? Just need to make that actually look good and actually work all the time. And the animation, of course, is terrible, right? The animation is terrible. Yeah, so this noise looks really bad. Let's look at the mountains. Because the mountains actually, the mountains look okay. The mountains are nice and smooth, I think. They're a little... Yeah, no, yeah, they're the same. Kind of the same way, aren't they? It's not as smooth as I would want it to be. Oh, that's so cool. Oh my god, I'm so glad. Oh, I'm so glad. Getting so close. That's a little strange, but that's okay. Wow. Wowee. What is that? Yeah, I feel like the lerp is not... This maybe needs to be a bit different. What happens if I do that? Do you think it'll be possible to have caves with branching tunnels? Yes, and I have a plan for that. Okay, that's even more wrong, I think. That was even more wrong. So my plan for that... so right now I have what Minecraft refers to as cheese caves, which coincidentally we did the same way. I did not model that part after Minecraft, but this was my plan all along, and it turns out Minecraft does the same thing. So one thing you can do for caves is called purlin worms, but that's not a completely deterministic procedural noise algorithm. I'm sure you're familiar with purlin noise. But it's like if you took purlin noise and stepped it through the world. And so it's like purlin noise with a time parameter. So you would need a start point and an end point, or rather a start point and then you would get an end point. But that's not deterministic, right? Like you can't pass in a point to that and be like, hey, is there a tunnel here? So what you do is you have to generate a set of noise that looks like noodles, essentially. And I have that here. Here's my noodle noise, right? Here's what that looks like. And so if you imagine this, but squash it down, stretch it out. So it creates horizontal tunnels that can actually be walked on instead of vertical ones. That's how you create branching tunnels. And you combine that with the noise I have here, where it's just all blobs. And that would create the cave system that you're probably imagining. Now, I can probably do a little bit better than this. You know, this is very vertical, so I think I can tweak the params here and get some noise that's a little bit better for that purpose. But that is what I plan to do. It's also what Minecraft does, coincidentally. Okay, so that looks bad. Let's actually let's just return that. I don't want a GPU dump. Wrong hotkey. But that way you can just, like, with that noise, you can just ask, like, hey, what's the value here? And you get whether there's a tunnel or not, right? With a purlin worm or like carving or something, you actually have to run that. if it's not deterministic. Well, how do I say it? It is deterministic, but it's not like, it's not a constant time operation to figure it out. Like you would have to walk the worm, the purlin worm, to figure out where it ends up. Okay, this might be even worse as well. Yeah, this is even worse. Okay, so we want, and I did get the changes, right? Yeah, I did. Okay, so we definitely want to divide it by something. Increment was looking the best. It was still a little not smooth. It's weird because some of it is smooth and some of it isn't. Oh, you know what it is? You know what I bet it is? I wish I had a side-by-side with my old algorithm to see. It might be the height curve that I'm supplying. So I have these curves here that influence, like, specific. Here's the height curve. And so I take these algorithms output a value from 0 to 1, 0 to 1, and then I multiply it by the whatever this number is, or where it is in the 0 to 1 range here. So like this is 0, this is sea level, right? So any value in between 0 and 0.3 actually gets transformed to underneath 0 to kind of create some little, this was going to be for like lakes and stuff like that, a little bit different now, but on the CPU this works you know, seamlessly, and you can get these smooth values, but I actually ended up having to pass this to the shader, and like of course the shader doesn't, it only has primitive types, so I can't pass a curve asset to the shader. So what I had to do was I sampled this 100 at 100 points in between 0 and 1. That's like the resolution I sampled it at, and then that's what I multiplied against the height. So I think that might actually be the issue here. But I feel like that would also potentially have influenced my old algorithm as well. And my old algorithm definitely wasn't this bad. But I'm just wondering if the effect is amplified now because of the marching cubes algorithm. So, interesting, interesting. And I tried the unscaled height. What if I... Or am I talking about nipple? Yeah, I've been the whole time, actually. You think I've been talking about Minecraft. It's actually nipple. This is a very pro nipple stream. It's a pro nipple space here. Yeah, so that didn't quite do it. So what, that like squashed it down. That like squished it. Okay. What if I didn't have increment there? Free the nip, hashtag hell yeah, brother. Hell yeah, brother. Oh boy. That's pretty cool, actually. That just amplified the height, didn't it? No, it's still not walkable, still very steep. And the mountains are just they're just completely cut off. Can't even generate those boys. Does it seem like the positive ZQ meshes are not even being generated? I think it may. That's a cool idea for an Easter egg. Wait, what is? God, this is that's so blocky. Times increment. Am I sure I don't want unscaled height here? Oh, that yeah, just make it like a perfectly like literally do it by hand, like make a nipple by hand. It's like perfectly like high resolution nipple. Oh yeah, oh weird. Procedural marching cubes does that sometimes. I see what you mean. That's funny. It's just like so out of place. It like doesn't even match the rest of the resolution. You know, throw a dick and balls in there as well. Why not? Why not? They don't call me my drawing for nothing. I keep feeling like I want the unscaled value here, but that didn't do it. So wait, what? This was what looked the best so far, right? What if I didn't do either? Have I tried this one yet? Have I tried this combo yet? A cave stalactite? Yeah. Hell yeah. This is what I just tried? That's what I just tried. Okay. Yeah, it's not smooth. It ain't right. So this looked the most right. Go back to that, make sure that that's what I was looking at. Yeah, that definitely is the most right. Yeah, the lerping just is not as smooth does that make sense? Does it make sense that it's doing this? Like, is this... Because I think I was talking about there being this kind of side effect where it's very marching cubesy. But I thought I could get around that by, like, doing the lerp properly. But is this just the side effect? Because the height map it's at the same resolution as the 3D noise, just only one layer, essentially. And so it should, I feel like that means it should have the same smoothness. Maybe just this value isn't, maybe I'm not doing this correctly. If vert height above vert height map value, we're going to subtract it to get the difference, and then divide that by increment to put it back into the vertex space. Why did I think I needed the unscale? I needed the chunk size. Why did I think I needed that? Primoxy. Hello. Chunk coordinate z times extent z and if I don't do times increment here, that's essentially the same as, okay, weird, okay, because that would have made this number smaller. And so the difference would be bigger because of that. I do it the other way. We'll do increment there. We won't do it here. I think I tried this already. No, that's I feel like it's the same thing. I feel like it's the same. Maybe a little. I think that's actually a little sharper, maybe. We divide. Yeah, and I tried dividing it by unscaled chunk size, right? And that just made it flat? No, it didn't. No, that didn't do anything, actually. Same shit. Same fucking shit. I would have thought that in increasing this would make the noise value smaller, which mean it would be which would mean that it would be smoother, because then it wouldn't need to lerp as far. Vert height greater than height at value. we should change the noise value into wherever the height map is. And I think anything greater than like a -1 here, or less than -1 rather, would be the same effect as I think what we've been seeing. Because I think this would be in a range of -1 to 1. -1 would essentially mean that, like, hey, there's no solid space until the next one. So that would be like the full lerp value. Junk ward Z times extent Z plus vert C, and then we minus extent divided by... Let's just not do that. I'm just curious. I don't think... I'm quite certain this isn't right, but... just curious. Yeah, now we're like way below where we need to be. Yeah. We just shifted everything down by a half chunk, essentially. Okay. And then we multiply it by increment to get it into a 0 to 240 space. Because height map value what do I use increment for out here? Oh, I don't multiply the height map values by increment until afterwards. I guess that would explain why something like this looked a little similar to not using the height map. Or not using the increment. Although this ends up looking smoother, though, I think. Right? Like, this is smoother. Slightly. It's very slight. Like, you know, like this, these, like, look, this is very smooth right here, right? But then it's like we get here and it just takes a, I kind of feel like this is the height curve issue. Because, like, if I were to change it to not use the increment, yeah, that's not right. That's not right. That is not even in the right, yeah, space. I mean, the height does change. Yeah, okay, I really do feel like it might be the height curve, actually. And which one of these do I need to divide by? I think dividing by increment here is actually correct. No? Okay. Ignore me. Ignore me. Vert height. So, oh, I'm applying that to the X and Y, not the height map value. Okay. Okay, so I take that back. I do need to use increment. But not using increment down here actually ended up looking okay, but still more steppy. Right, okay, so like... Is this just completely flat here? I feel like that's completely flat, yeah. I mean, this isn't, though. I can see a bow right here. I'm gonna look at that spot right there. Remember this shape right here. Is that better? Or is that the same? I feel like that's slightly better on this side over here. Although it looks pretty similar, right? It looks pretty similar. I feel like this one's better. Slightly. Okay. Let's just try increasing the height, the curve resolution. I think I can do that pretty easily, right? Where was that? It's in height map? Yeah, curve values. Let's just double it, maybe? Excuse me. Height map generator. Let's take a look in here. Oh, I've hard coded these. Okay, those need to change as well. I wonder, can I, if I put this right here, can I do this? Can I do that? So run the live coding to pick up that change. And let's compile shaders as well. Okay, it did not like that. It did not like that. Variable length, yeah, it doesn't like that. Okay, I have to hard code these. Okay, I'm gonna run the bathroom while that builds. BRB. Can we get untangleable chords yet? 2025. This is the future. We should have chords that don't get tangled. Anyways, let's run that. See if that gets better. Okay. I don't think that made a difference. I don't think that made one lick of difference, actually. Let me make sure I'm actually using that right. You can go away now. Yeah, I am passing the curve resolution in here. Make curve values buffer. Yeah. That did not seem to make a difference. Okay, so it's the algorithm's fault. It's so weird to me. Like, why? Like, look how close these verts are in the Z direction, and then like those ones are even more. But then like, you know, I'm looking here and I can see like a very gradual. I wonder. Okay, so I think I need to move verts that are above as well, right? I think I need to... Yeah, okay, I figured it out in my head. Hear me out. Okay, so we have a... Hear me out. Okay, we're marching this cube. Right? And each of these verts are like the corners of the cube. And I think what's happening is like I need to check the verts that are within that have I need to do all of these, and I was just doing these. And so when this, like if we have a height map, get rid of that. If I have a height map that's steeper, or let's say it does something like this. Okay, sure, we're gonna use the thick boy. Or it does something like this. The next cube right, it would only have that vert, right? And there'd be a cube here, and it would only be that vert. So I think like it needs to be the cubes that are within half, not necessarily just the ones that are above the height map. And so they should move up or down. And if they're completely above the height map, return -1. I think maybe. So I think the steepness here. Yeah, okay. My explanation probably sucked there, but in my head it makes sense. I think I know what I'm doing. Famous last words. Okay, so I need if the absolute value ABS yes, call it ABS height diff. If ABS height diff, divide that by increment. What's the threshold here? It would be no, actually I want that, right? Because I need it I need like float cell half size. Increment divided by 2. I think that's right. Yeah. If this absolute height diff is less than cell half size, then we are within that chunk. We are within the height map is intersecting this. Half size, yeah. So this would be true for one of the verts, but not the other one, depending on where it is in the range. I'll say else if do I want the absolute value for this? Because I think at this point it would still generate floating stuff above the terrain if I did this. I mean, let's just see what happens here. This isn't going to be right, but I'm just curious. Yes. Okay, weird. 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 It looks good in here. Ish. I mean, those are still pretty steep, aren't they? Okay, so we're just... Yeah, I guess we just created little pockets. I think I see what happened here. Right, because all the ones above it are still being solid space. So, I mean, the other thing is, like, if ABS height diff is greater than cell half size, let's return -1. And in that way, that'll get rid of the, we'll chop everything off, I think. Still got pockets, but we don't have the floaty bits. Yeah. Okay. This, I guess, needs to change. Let's not do the absolute value. Cell half size is increment divided by 2 absolute. Yeah, change the name of that variable. Height diff. If height diff is less than cell half size and height diff greater than negative cell half size. If it's within that range. Fatal error? Right, because we have that. That was your issue, right? Yeah, that was your issue. Okay. Okay, we compiled properly. Okay, still nothing. Still not what we want. Very interesting terrain, though. So if I didn't do that, still the same, but we have vertical noise. Okay. Okay, what's the logic here? Because it's like I want to move it up or down, and I think maybe this needs to be ABS absolute value. No, because that's going to mean it's positive. I actually want the negative absolute value. That's looking more like a height map. Okay, but I have holes. Interesting. Okay, no, I don't. No, I don't want that. No, I don't. Okay. Let's split these into different conditions. If height diff greater than 0 and height diff less than cell half size, then I am above the height map and I want to move lower. But otherwise, if I am less than 0 and greater than cell half size, then we want to flip these. Then I think that means we don't need that. But this may just give me, yeah, what I already had. Yeah, and if I do if it's above height map, get rid of it. I think this literally returns me what I was already working with. Okay, never mind. Thought that would... And you get the terrain still is not even smooth if I do this. Did you pick up on that? Did you actually get those changes? Height diff is greater than... What if I just said if vert height is greater than vert height map value? Just do it that way. Still? What? Yeah, this is, it's creating holes. Okay. Okay. I'm trying to think here what I want. I'm quite confident that what I tried to explain here is the issue. Like, everything's fine here in this case when the height map slope does not exceed the cell. I'm pretty sure that's why some of them look fine and the other ones are like steep. And so what I'm trying to do is like only move it up or move the noise values up or down if it's within the half size. So like this one would move down, you know, maybe this one would move up, and then that would hopefully smooth it. I can't tell if I'm just not doing that right or if that concept overall is not correct. Oh, and this needs to be... It would never be below 0 though. Hang on. Vert height minus height map value. If that's positive, then that means vert height is higher. And so we would want to subtract vert height. Height diff, if it's... Yeah, no, that was not right. That was not right. Okay. I feel so strongly about this conceptually. I do not feel very confident in my execution of it. Is this even the right cell half size? We are subtracting vert height and vert height map value, which is an incremented, which is in incremented space. I wonder, do I need to like, I wonder if I need to convert this. Does that make a difference? I'm gonna assume no, but just in case it's being weird. No, that looks effectively the same. See, like, ignoring the overhead here, like, see how smooth this looks here? And then you get to this part and it's like, bam! Fucking bam. Yeah. Okay, so subtract the vert height map value. Height diff will be greater than 0 if we're above the height map. Okay, there's effectively what I had. I think this actually looks a bit worse. I think this is actually steeper. This is more steep. So this is worse. And doing that just like, they give me empty terrain, so that's not right. If I don't increment that, I don't think that's right either, but this will give me even sharper terrain. Yeah. Even sharper terrain. Look back at the paint example here. And of course, actually, the height map values are not actually going to be that smooth. Okay, let me undo some things here. to undo some code. So this should be my old algorithm. I want to see how smooth we are here. File shaders. Dude, look how fucking smooth that is. That's what I'm expecting. Okay. Okay, so now I know that I've reminded myself what the height map looks like. I kind of feel like, to simplify this a little bit, maybe anything over the height map value, I should probably be doing this. Wait, what happened here? Height diff less than 0 and greater than... Okay, yeah. Okay, so I think actually I'm just going to do that. Greater than or equal to 0. I think that makes sense. Greater than or equal to 0 is fine. Yeah, so anything above the height map, just move down to the height map just to simplify things a bit. Is this going to return the right? I don't know if this is going to return correctly here. Okay, no, it does, okay. It's still, you know, obviously not smooth. Let's just do negative cell size. Do the entire cell rather than a half cell. Okay, that was worse. Very interesting plateaus though. Kinda cool. I hate that my character keeps going through the mesh like that. It's very frustrating. Anyways, that was not the answer. height difference is less than 0, that means I'm below the height map. No, it doesn't. Vert height. Oh yeah, yeah, it does. Yeah, it does. Yeah, means I'm below. Yeah. What's the entire chunk size? And so if I just do something like this, well, let me look at this again real quick. Look at this one. Yeah, very steppy. I think we do have some smooth values like here. And then if I were to just delete that part. Yeah, that's actually, yeah, this is the same as what I had originally. And this should be a negative value. Clamp this between -1 and 0. Word, okay. What are the clamp parameters? Am I doing that right? Intrinsic functions. Clamp. Yeah, I do have the parameters right. Is this not a... This should be a negative value, no? Vert height, if vert height is greater, or no, it should be a positive value. Okay, so 0 to 1. Okay, yeah, so no difference. No difference. No difference there, which should be the case. I guess that was just a bit of a test. And here we're back to some bad looking terrain. Okay. Yeah, so trying to move them up, move the verts up, is not... It's actually making it look worse. What if I divided by 2 here? Just out of curiosity, what if I divided by 2? Is that smoother? I can't tell. Yeah, and like, hopefully that's float. I would hope. I would hope that's already doing float division. Okay, so divided by 2 didn't make a difference, which is kind of interesting. I mean, it would make a smaller number, right? I feel like that should have made it less steep. Just overall, it wouldn't have fixed the issue, but I don't know. I don't think so. I don't think it did that. What if I just returned 0? It doesn't want to be 0. It wants 1. Maybe I just return 1. I am predicting this to be more steep. Yeah. Okay. And so that means if I did 0.0001, this would be less steep. No, it's not. What? Question, what? I'm confused. I guess that just kind of made everything flat. Okay, so okay, I think that makes sense actually. God, what is the answer here? What am I doing wrong? Yeah, I feel very strongly that this is the issue, right? So we go from this layer, this is one layer of cells, right? So we go from this layer, where just the top two vertices are above the height map. So those get squished down. They go down. And because all of them are above the height map, they all get squished down the appropriate amount. But once we get to a cell, once we get over here, it's like the bottom cells are now above the height map. Or the bottom verts. Did I say that right? So it just goes drastically to the next level. Because we're only moving down. I mean, I feel strongly that we need to move up as well. Even less smooth. Yeah, okay. Word. Map is less than 0, and the height diff is less than 0. That means vert height is below height map. And if the height diff is greater than cell half size, we do the opposite. What if we didn't do the opposite? Yo, is that better? That looks better, right? That looks better. I mean, there's still a little... I think this is better. Yeah, that nipple isn't nipply anymore. I have unnippled it. Oh, okay, this looks better. Still some kind of bumpy points. I mean, I could just increase the resolution, maybe? But there's an interesting... Yeah, this section still looks bad, which is interesting, would be the word for it. The rest of it actually looks okay. It's still not quite as smooth. Yeah, it's not quite as smooth. This does look better though, right? Okay, so this is what it should look like. It's just without the cells punched out. I'm onto something. I think that undid. Yeah, undid the smooth. Yeah. Okay, so I think I don't know why this is working. I don't know why this is working. But I think what I can do is maybe check if the space is like empty space or something. There's some code there that I can check to make sure that the height map gets punched out. I mean, that was it. That was it. Boom. Boom, baby. Yeah, baby. I think that's it. I think that's it. Maybe I can compare real quick. Let me turn on the old algorithm. I'm curious at what this looks like because this is quite pointy. But I think maybe the old algorithm looks like that a little bit here. And I'll test this out with some different world seeds. Okay, live coding. I'm back. And I pressed the W key 1,200 times today. A lot. Yeah, these are a little pointy too, so I think we have it. I think we have it. Yeah, I think we got it. Can I get a hell yeah? I think we got the smoothness figured out. I think we fixed it from being too sharp. So I think we got the height map is being properly built by the marching cubes now. Okay, so I have essentially the same outcome as before, but a million times fucking better. Because look, I'm not generating. Oh my, this is like holy shit better. Like, this is way better. I mean, it's crazy. It's crazy how much better this is. Like, I can't describe to you the hackiness that my algorithm was before, and now it's running like a well-oiled machine. Building the mesh all in one fucking step. Like, look at how much code. So see this code right here? I can't spot the difference. That's good. That's good. That's beautiful. So like, look at all this code that I get to just delete now. This whole function. Oh my god, like I can't even explain to you. And this whole function. And this whole function. And like all these different geometry script things that I'm doing that were so complicated and not deterministic, actually. I just get to delete them. Oh my god, like it's... Yeah. So here's essentially what was happening, right? The way I was doing this before, like... What I wanted was... I have set a 2D noise, which represents my height map. And then I have a set of 3D noise, which is going to represent my caves. And I was like, okay, how do I connect these two things together? I have this marching cubes algorithm that I use that I can build a 3D mesh out of. But I want to connect the height map to that, right? And then I want the 3D noise to kind of subtract from the height map, like what we see here. I want it to punch through where the height map is and expose the caves and stuff. And so what I was doing, the flow that I was fucking doing, was I would build actually the opposite mesh here. Like, all this would be actually a solid mesh. This empty space here would actually be a solid mesh. And then I took the height map and I had to make a cube out of it. I had to solidify the height map. And so that's why before, when I looked on the sides, I couldn't see through it. They were solid chunks. It was literally a cube. And then I would take that 3D mesh and do a Boolean subtraction method on it, because that's a built-in function. And then that's what would allow me to connect the two together in a way that I don't have to go through each vert and triangle and like patch them together, stitch them together. And like the amount of things that I had to do, right? Like, what if a height map, you know, goes outside of the range of a chunk? Like, what if the steepness of a height map goes through multiple chunks, right? So I ended up like building the height map for every chunk, but then like cutting it off if it was over the chunk bounds. I had to extrude the height map down. I had to actually build the height map as a separate mesh. And like, hey, if this is completely under the height map, just make it a box, because it's just going to be solid space, right? And here's where I go through and I come up with the vertices for the height map here. Add those to a buffer. I have to extrude the height map, so I add some more verts. I have to go through each edge vert and like shift it down to the lower bounds of the chunk. And then, you know, build that. And then I can append that. I have to build out the Boolean mesh, which is like the fucking 3D noise and stuff. Oh man, like I just can't even explain. It's kind of hard to explain how much better what I'm doing is. Like, insane. It should be more efficient. The thing is, like, this code was actually like parallelized quite a bit, so I think I'm not going to see a timing difference, but I will see like more of my compute threads are going to be freed up, right? Less compute power needed on the CPU. I'm just not going to notice it because it was very parallelized. And now this is all the code I need now. That's it. Kind of insane. How did I figure out the new method? So I was watching these Minecraft videos on how they did it. And that gave me an idea. They actually do something a little bit different. But they talk about how they build their 3D terrain with caves and stuff. And what they do is they have I guess they don't use 2D noise anymore. I still like the 2D noise because I feel like I have very fine-grained control over what the surface of the world looks like that way. But I digress. They talked about a height bias, which is essentially how they create a de facto height map. They have this 3D noise, and they have a height bias curve. And essentially what that means is like the higher up in the world you are, the less the 3D noise is going to be represented. And so you have like a kind of like a, maybe world 0 is like what you would call sea level. And so the higher you go above 0, the impact of the 3D noise values starts lowering. And that kind of creates a smooth terrain. And so that gave me the idea for my implementation is like, okay, well, if I had the height map values in here, I can just move if you understand marching cubes, you'll understand what I did. But like in marching cubes, you're considering a cube, right? And so each corner of the cube is a vert. And you have the noise values for each one of these verts in 3D space, right? But this noise value, and for me, it's in between -1 and 1. But you might have -0.4 here, and then you might have, to make it easy, 0.4 here, right? And so 0 is where it changes from solid space to empty space. And so part of the marching cubes algorithm is to check each one of these edges and come up with the point in between where empty space is. And that's the lerp that I'm talking about. If I say lerp, this is what I'm talking about. And so 0's right here. So we would lerp between these 2 points based on these values here, come up with where this point is here. And I would do that for each edge, right? Like if I had these 3, and this is probably getting kind of hard to look at. Let me Control Z a bunch here. Okay, I can't go any further. So imagine that example, but here, right? So if I had, let's say I have value here and a value here, then I know I need to connect those two. And so I would draw the triangle like this. And part of the algorithm is that there's only actually 256 combinations and only 16 completely unique. The rest of them are just the same triangle, the same edges connected, just in different orientations, right? And so you can extrapolate that to the other sides, right? And create the triangles like that, or if like you have one there, you have one there, you have one here. That would kind of make this like 3D, it's connected to the backside. So what I ended up doing was I not only am doing this lerp like this in between, this point and this point, I'm also checking if either one of these points are over a height map, which would go through the cell, potentially go through the cell like that, right? You have to use your imagination a little bit because the height map, we're not exactly looking at it in 3D space here, but let's say it's above, then I actually move the noise value down. And so instead of lerping between here and here, because this point, I moved it, I essentially moved it down. I'm not actually moving it down, I'm actually just changing the noise value. I now lerp in between here. And that created the height map for me. And then I just said anything above the height map, just ignore. Just move everything above the height map down to the height map. And then I said anything below the height map by less than a cell, move up. And that connected everything. And like I did that about, I don't know how long I've been working on this, maybe an hour, 2 hours ago or something. my initial, I tried this and it was like very steppy. Like it was not smooth. And that was because I was only moving down. And so when we had a steeper section of height map that would go, you know, through the cell vertically, it would that would shift up a cell essentially and make it steep. So I just figured out how to make that not steep and smooth, and now I essentially have the same fucking thing that I had before, but there's no artifacts. There's no all this extra code. There is no solid chunks, meaning the problem that I was explaining earlier in my stream, if you were to, you probably weren't here, but if you go back to look at it, I was showing, and let me actually fucking look at this. Let me pull this up. Hang on, where's my damn channel at? Where's my damn channel? Oh god, look at that. I'm gonna pull it up on YouTube because that's just like a million times easier to go back in time. So let me try to find a section here. Okay, come on, my drawing. Move the camera over a bit. Okay, there was a good example. Okay, so one, like, here's all the artifacts. Like, you can see the chunks are not lining up properly. There's this chunk up here isn't even, like, correct. You see there's some... this is what I'm talking about when I say artifacts. Like, some of the edges of the chunks are not being subtracted correctly because they're all solid chunks. And I'll try to show what that looks like. If I go to the edge here... Come on, go to the edge, buddy. Go to the edge. I want to look from outside. Okay, that's kind of a shitty example. Here we go. So you can see the sides of them are all filled in, right? Oh, I missed it. But you can, like, that's because I was literally creating a cube for each chunk and trying to subtract from it, and that's where all this weirdness started to happen. And if I show the... Oh, here we go. Is this where I'm looking at it? This is the nav mesh generating on it. And so the problem is, like, in a space like that, I think the nav mesh just didn't get there yet, but come on, go back. In a space like this, the nav mesh would generate on here, which was not correct. That was not right. I think the nav mesh just hadn't generated that far yet, but, and every chunk was like that. Like, you have to imagine this in 3D space. Every chunk was like that, underneath the terrain and everything. And PCG, when I was spawning assets on it, it would do the same thing. It would spawn assets here, even when I didn't need them there. And that's going to be a massive issue, because I'm serializing the assets and then reading from the serialized points for my ECS system for when colonists need to go find, like, some food in the world, to, like, go find mushrooms, go chop down trees. I'm spawning shit underneath chunks in unreachable space. Like, that's not good. I can't have that, essentially. And so you go from a system like this, and maybe I can find an even better example of the nav mesh. I know I showed it at some point. Okay, there's an example. There's the nav mesh being generated. It's being generated underneath. Like, there's chunks on top of that, they just haven't been generated yet. Like, and I think I go inside of a chunk. I'm trying to point it out there. Turn up the playback speed here a little bit. 1.5. Yeah, there you go. I just went inside of a chunk. Let me play that back. I'm gonna go inside this chunk, and you'll see there's a nav mesh in there, right there. You see, like, that's not supposed to be there, and like all this stuff. So I went from that, and, like, not to mention all the extra geometry that is just being rendered as well. You know, like, all the additional, like, how hard the nav mesh has to work to calculate where it needs to be. There's just extra verts everywhere. To this, to, like, what you would expect when you peek under the hood of Minecraft, right? This is just, it is so much fucking better than what I was doing, and I figured it out in, like, a fraction of the time that I did the rest of that shit. That looks great. I thank you, dude, thank you. And so yeah, now I actually am going to get to do what you were mentioning before with the terrain tunnels and stuff, the cave tunnels rather. But I mean, this is crazy. I mean, like, what I didn't think I would be able to do this with the height map. That's why I was doing it the way I was doing it. Was because I didn't think I could get marching cubes to actually work with my height map. And I thought I was going to have to do something like what Minecraft did, which was you have to apply a height bias value depending on the Z location of each vertex. I didn't have to, and I may still do that. I may have, and that's why I'm passing in, and I'm glad I set this up this way, but I am passing in the height map to my marching cubes shader, and it's a read-write buffer, so I can actually modify the height map a little bit as well, which is cool because now I can do both. I can have a height map bias, as well, or rather a 3D noise height bias, and I can say like, okay, how much should this 3D noise change the height map? Like maybe I want it to be, maybe I want some overhangs and stuff like that, and I can actually say that, and I can do that based on a like some noise, right? Like you picture 2D noise like this or like this, and I'll say anywhere there is black on a noise like this, anywhere there's black, you know, that's where I want the 3D noise to poke through. So picture it like this, but inverted and sticking out, right? And that could create overhangs and stuff like that on the height map. And then that would smoothly blend, because each one of this is a 0 to 1 value, 0 black, 1 completely white. That would smoothly blend away from that, back into the flat height map and create really, really interesting terrain. And I can have the control that I want over the explicit height map and the smoothness that I want over the explicit height map, and I can still have really interesting, you know, mountain type landscapes. You know, these are kind of mountainous too, but these are just borders. So I'm talking different things. Now, let's go back to the seed that I was showing off in the video from earlier, because that's a really steep and interesting seed, and I want to see how much better this algorithm does it. Potentially faster too, although maybe not super fast still. Or rather, not much faster. $13 seconds, so I think a couple seconds faster. Ooh, okay. So I think we have like maybe an off by 1 situation here when we're transitioning between Z chunks. But I mean, interesting. Yeah. What is happening here? I'm glad I checked this one. Yeah, you can see where the Z chunks split. But yeah, I mean, I just think this like looks really cool, right? Imagine those connect perfectly, but you know, you have this terrain that you're walking through, and you see this big ass cave, right? You can just like step up here and peer over it. And, you know, all of Minecraft, I do expect there to be some ore sticking out here that you can go mine and stuff. Yeah, this looks so much better. Like, there's no giant... Like, there was just a massive cube here at the top. I'm quite happy. I am quite happy. What is happening here? What is happening here? It's really cool that I can also peek through it. I can see where all the noise is. Like, that just makes it easier for me to find things that I need to look at to test for testing purposes and stuff. Okay, so these do happen to be the edge of one chunk and the beginning of another in the Z direction, and they're just not lining up properly. Okay. Okay. What is the issue there? Let me comment this out. So this is going to be... That was the fix for this method being a little too steep and the height map was not smooth enough. Okay, that does not fix the issue, though. It does in some places, actually. Does it? So yeah, that didn't fix it actually. That did not fix it actually. So our height map is not connected in the Z direction, but our internal noise is. Our 3D noise is. And I can see that by clicking on these two, and there I can see they're lined up. There's no gap there. So our height map, okay. And that didn't seem to change it. And so this right here is what I'm talking about when I talk about it's like a little too steep. There are some smooth sections, but then it's like there's these little sections where it just goes from one to the other value, and doesn't look, it's not as smooth. And so that's what this little section was for there. So coming back down here to like the same area, you can see there that step up is not there anymore. So yeah, it's a lot smoother. So we love that. We love that for me. Okay, so what is happening here on these edges? So I already know that the edge, like a steep mountain like this, is going to look very terracey because of the height curve. Like the height curve is what is extrapolating these mountains so high. And the height curve is this thing. And it's very steppy like this and not smooth like this because I have to sample this and send it to the GPU. And so that's why it looks like that. You know, not a huge deal. I think it actually looks kind of cool. But why aren't the edges connecting to each other? Is the question. What condition, like what case is happening here? Whoa, what the fuck? What happened to this cube? Wait, what? Wait, is that always the case? Or was that the one that got messed up in the breakpoint that I had? Okay, yeah, that one just got messed up. Somehow. I don't know why. Okay, maybe that one's very off. Okay, so the Z lines up. It's the X and Y that I guess don't. I am doing extent -1 here. Does that matter? Minus extent z divided by 2. Those edges along the top. Is this because that? If the noise values are equal, I mean, is this the case of the vert points just being exactly equal to the height map? Or is it... actually, this feels like it may not be right. What happens if I don't do times increment? May look very strange. That, I think, made it even worse. Oh, that fixed those issues? No, no it didn't. No, it didn't. Okay. Coordinate times z times extent. -1 here, maybe? Oh my god, was that it? Oh, that was it. Oh, booyah, baby. We are so fucking back. Oh, we are so back. Let's fucking go. Holy shit. I was actually getting a little worried that that one was gonna escape me. Oh, it looks so good. Oh. Sorry. Excuse me. How'd you kids? Uh-oh. Okay, what happened there? Oh, okay. Okay, so we have some tears, it seems. Interesting. What is happening? Oh, weird. That is just a really weird section. Am I casting shadows on these? Cast shadow. Dynamic shadow. Yeah, it just looks... I feel like it should be darker in here. Anyways. I wonder if we're just not hang on, let me walk over there. Let me see if I can even get over there. Maybe we generate that chunk. Maybe that chunk just isn't generated. Oh, that fixed it, yeah. Okay, that chunk just isn't generated yet. Because it's in a radius around the player, so you have to imagine like kind of a circle happening. And I think that circle kind of ends prematurely. Let's walk over to that one and make sure. I don't even know how the hell I'm going to get over there. Jesus. Oh, Jesus, I'm gonna fall. No! No! Nice, stuck it. Stuck the landing. Yeah, I need to work on this material too. I don't really know a whole lot about materials. And so I just threw together this landscape auto material. It looks a little shitty, I'll have to admit. Okay, I'm just trying to get over here. Did we generate that chunk? Where am I? There I am. I don't think I'm actually... I may have to go over here and walk around this big mountain range here. Okay, we're exploring, guys. We're exploring. I made a nice landscape material once, but I forget how I did it. Yeah, there's some good tutorials out there for it. I just like... For me, it's not a... Of course, I'm doing hard mode, so it's not as straightforward because I have, like, you know, the internals to deal with. So it just goes from, like, one to the other. It's all just, you know, lerping between things based on the height. So just, you know, a simple one isn't too bad to come up with. But then they're, like, it's like the stuff you do to the textures to, like, you see how this texture looks completely different when you're close versus far? I don't know why that is. I don't know why that is. And like UVs and stuff like that, that's the point where it gets into like, okay, what am I doing here? Okay, did I get that chunk generated over here yet? No, still no. Still no. Oh, we have another zone over there now, though. Look at that. So pretty. Wow. Wow. Okay. Did I get that chunk generated? No, still no. I'm getting like farther away from it, I swear. Okay, I need to head back this direction. Whoa. Oh boy, we gotta jump. Ah, nuts, I got stuck. Okay. Did we get it generated? God damn. Okay, let's rebuild so I can go back to the start. Uh-oh. Did one... What? That did not happen the first time. So does marching cubes essentially deform a cube into other shapes based on noise? Deform would be the wrong word there. Marching cubes connects the edges of cubes together into triangles, and those triangles make up a mesh. So let me find a little image here. Yeah, so here we go. This is here are the, what is it, the 15 unique combinations of triangles that can happen. So when I say it, this is a cube that's being considered, right? And then you have a noise value at each point, each corner, each vertex. And like you have a threshold for what you consider solid space versus what you consider empty space. And so if you have a solid space value above that threshold here and an empty space over here, then you make this triangle. And the same, you know, go on until, you know, you handle all those scenarios. And like there are pre-built marching tables that you can use. Like here are mine. Here's all the combinations. And like each one of these numbers is like, I think this is just like empty. And so you have like a number assigned to an edge and where the point is, and then you do some lerping and stuff like that. So the geometry of your caves are some combinations of these shapes? Yes, precisely. These shapes, so there's 256 total, but only this number of completely unique. The rest are just different orientations of these ones. And so yes, it is a combination of these rotated differently. Yeah. And there's some pretty good videos out there. Yeah, this is the one I've watched.
IRS e-file is now open.
Oh,
Snap your
it.
W-2
Stop
and
it.
file your taxes 100% free.
Hello and welcome to a new coding adventure. Today we're going to be looking at marching cubes. I'm afraid that's what passes for humor on this channel. Now, before I can get to the actual marching cubes, we'll need some function that takes in a point in 3D space and gives out a single value. Then, if we have some region of space that we're particularly interested in, we could use that function to sample points at regular intervals inside of it. The highest value I got with my particular function was 16, which I've colored white, and the lowest was -34, which I've colored black.
Yeah, it doesn't matter what those numbers are as long as they're
I made a little slider here
consistent.
called the surface level. As I move it up,
Like
you
mine's
can see that
-1
the
to
points
1.
with values below the surface level will disappear. So those points we can think of as being in empty space.
And this is the ISO
while the
level, is
points
what they call
actual
that
above
value
the
there.
surface level
That's your
are on the
threshold that I was
surface
talking
or
about.
inside of some shape. The goal of the marching cubes algorithm is to construct the surface of that shape from triangles so that we can display it as a mesh. To think about how this works, we can simplify the problem to just a single cube. There are 8 corner points, each of which can be the inside or outside of the shape, which gives us 2 to the power 8, or 256 different configurations. For example, with just one point inside the shape, we get a single triangle over here.
And that's because like that's like your solid space value, and then you lerp between for each edge that this is on. So there's 3 edges, right? So whatever this value is, like for me, this, if this is -1 and this is 1, then you would get a point halfway between the two. That's where your ISO level is, or 0 for me. Let's say this is like, this actually looks a little off-centered, so this may be like, this maybe this is -1, and then maybe this is like 0.8. And then so 0 would be like right here. Or no, opposite, -0.8 and 1. So 0 would be closer to this side. And you do that for each value, and that gives you the triangles that you need.
If the point above it is also inside the shape, we get a little rectangle made from 2 triangles, and so on.
And then your
As you can
triangulation
see, some of
tables
the
give you
configurations
that.
get pretty wild, but
You have to do the
thankfully there are
lerping,
only
though.
14 unique cases. The rest
14.
are just symmetries of those. But still, figuring this out is a tremendous headache that I did not want to undertake, so I took the easy way out and downloaded a triangulation table like this from the internet. So let's take this case for example.
And it was this algorithm was created by a guy named Paul Bork back in the 80s, and he was working on medical imaging software for bone scans, and he needed something to visualize. He needed an algorithm to like visualize it.
Corner 7,
And that's what marching
5,
cubes
and
came
1 are active, which we can interpret as configuration 10100010, or in a more familiar number system, configuration 162. This
So yeah,
is the
you just
code
use
for
binary
calculating
to
that
come up with the
index, just in
ID.
case you're interested.
In the
Now, I
triangulation
can take
table,
this
the index in the
and
triangulation
look up
table.
the corresponding entry in that triangulation table. This tells me to join edges 501 and 540 and 7611 to form 3 triangles. So in code, I look up the triangulation info here and
I'll
loop
link that
through
video. It's a
each
good
edge
explanation.
index.
That does not give you an implementation of it, though, unfortunately. You got to do that on your own, I suppose. That's such a counterintuitive way to create shapes. I mean, I think if you tried to come up with a way to do it, you would realize that that's actually the easiest way to do it. And I actually tried to come up with my own way to do it. And due to 3D space having a lot of edge cases, it's actually really fucking hard. And like, you need to join the triangles. Like, it's one thing to create a height map mesh. That's pretty easy, relatively easy, because you know what direction primarily because you know what direction the triangles need to face. They're always going to face the same way, and in computer graphics, you've got to connect to create a triangle. It's just 3 verts. You got to give it 3 verts, but they have to be in the right order, counterclockwise, in order for that to show up. Like if these were in the wrong order, it would be invisible from this direction, and then I would look up and I would see it there. So for the height map, it's not too bad, but when you have 3D space and it could be any orientation, that's a lot more difficult. And so I think if you tried to come up with a way to create shapes in 3D space, you'd probably get to something very close to marching cubes. And there's some variations on the marching cube algorithm as well. Oh my god, I just like bounced off. Whoa. Oh, nuts. Pause right there. Did I get that? Did I get that? Okay, it did generate. Okay. So we've confirmed that those missing points are just chunks not generating yet. Perfect. Okay, and I think I can make this a bit better. No, I think this would be the same. So how does the algorithm incorporate noise? So that's where you lerp between the 2 points, right? Because each vertex in the cube has a noise value associated to it, somewhere between, for me, -1 and 1. And so, you know, it has some decimal each vertex. And then whenever you have a cube that has an edge that goes from empty space to solid space, that goes from a negative number to a positive number, you lerp between those 2 vertices to where 0 would be, and that's where the noise comes into play, and that's how it smoothly connects. And if you don't do that, you just end up with a almost Minecrafty looking world. It's like Minecraft with corners. And that, because you would just be connecting with an alpha of 0.5, you'd just be connecting halfway between each point of the cube. And so you would still get the shape, but it just wouldn't be smooth. It wouldn't be lerped, because what you're trying to do is you want the point where the noise transitions from empty space to solid space. And that's what the lerp here does. I hope that makes sense. Delete code. Delete some code. Wow, yeah, I'm glad I'm not... I'm glad someone came up with that before. Like, can you imagine computer science in the 80s, the 70s and 80s? I mean, complete Wild West. I can't even... Those people who came before us, absolute giants they are. I stand on their shoulders. I truly stand on their shoulders. Okay. Yeah, doing that in an old terminal would have sucked. Yeah, for sure. For sure. Fucking MS-DOS representation. Oh yeah, I'm just hard coding the chunk sizes. Okay. Okay. So let's fucking delete all this shit, man. Fucking delete it all. Burn it down. Down to the ground. Look how much code I'm about to delete. From line 138 to 415, gone. Beautiful. Absolutely beautiful. Nothing gets me going more than deleting code. That really just gets my jimmies going, if you know what I'm saying. Absolutely beautiful. Chef's kiss. Chef's fucking kiss. Okay. Okay. This is committable. You can commit to this. Okay, I was expecting this to be a multi-day journey, and I finished it within a stream. That's amazing. Rewrite marching cubes to build in height map. Yeah. Let's get some performance samples here. I want to see. Let's go to back to seed 19. It was a nice flat one. So now you're just ready to plug in some Perlin worm noise and you're ready to ship it. Almost. Not going to use Perlin worms, but yeah, I'm ready to do some noodle caves. Okay, 14 seconds. That wasn't too bad. Let's get a trace in here. I want to get some runtime performance. So yeah, I stay pretty much at 120 FPS as those generate. I dip down to about 70. You hate to see it. You hate to see it. I hope I still have the code that like completely bypasses marching cubes if the chunk I'm generating is completely above the height map. Not too noticeable though. Okay, let's look at that. Well, most of that was just the nav mesh. So the shaders probably were just quite fast. Here's the shaders. Marching cubes, 14 milliseconds. Yeah, that probably has to do with the extract buffer pass when I'm extracting the height map out of there. So I did add like a bunch of data to get extracted. So happens. Let me look real quick here. Oh no, I'm not. Oh no, that's the 3D noise. Height map vertices tries. I guess I wouldn't necessarily need to, although it would be easier this way. It would be far easier. I guess I'll keep it like that. Let's say if I have the vertices, I can figure out the adjusted height map after the fact, and I won't have to send as much data to and from the compute shader, or rather from the compute shader. Yeah, marching cubes, 14 milliseconds. That's a little high. That is a little high. I do have some game thread wait time, waiting for that shader to get done. The height map, 13 milliseconds as well. Jeez. Okay, so it's running a little slow on the render thread. I think one thing I can do there is actually... Can you stop whining, bro? You're very noisy. I think one thing I can do here is actually like just reduce the Z height of each chunk. Like maybe a chunk in the Z direction is only half the size as X and Y, and that'll allow me to generate points a little bit faster. It sucks that I only have one thread to run the compute shaders on. I mean, one, because like the GPU is multi-threaded, right? But there is a blocking thread within Unreal Engine. And I know there was there's this built-in thing into Unreal Engine for async compute shaders, but it only works on Xbox. And if I'm understanding it correctly, if I were able to use that, I would be able to run this across multiple frames, which would be desirable for me. So I hope maybe someday they'll get that working. But yeah, I guess it's just the mostly the nav mesh. Okay. So now what I can do is take this noise. Can I stretch this, actually? What happens if I just... If I just multiply this, it just gets bigger, right? How would I stretch the actual noise here? Well, it doesn't matter, because I'm gonna need to do it in the shader anyway. That's just for reference. Noise generator. Okay. What if I rotate it 90 degrees? I mean, I would still have the same issue because there's still some going sideways, you know? So I need it to be stretched so they just go naturally more sideways. Yeah, and I would need to copy over the noise params for the noodle noise. Tiling, filter width, level scale. Could I change any of these? Scale? No. I also want to be able to reuse this if I can. I mean, I could just stretch the values after the fact on the CPU, which wouldn't be too bad. Let's just do that. It'll make it nice and reusable. Means I need another one of these. Let's rename undo that. Let's rename this. We'll call it Cheese Caves. Oh, the sneeze escaped me. We're going to call this Noodle Caves. Okay, so we have two sets of noise parameters there. Now I need to pick off two compute shaders. Let's just copy this. Rename this. Noodle noise, cheese noise. I did cheese up there, noodle down there. Now I need two different, actually, carriers for this. Oh god, how am I gonna actually combine the two noises? Essentially lay them on top of each other, so I would just add the values? Or would I get the average? Or would I subtract the values? Well, let's still combine these on the CPU. Just so I can figure out what I'm doing. And then if we get that working properly, then I think we can get to some more fancy stuff. Then I need like a combined combined 3D noise data. And that'll go in there. The noodle noise done. Handle noise finished. If B cheese noise and noodle noise, is that the right? Yeah, that's exactly what I was going to paste in. Good. Good job. Okay. So we're kicking off two generations for noodle noise and cheesecake noise. Now it would be nice to just do this together, and maybe that's what I'll end up updating the shader to do anyway, so that way we just kind of like get rid of a whole frame worth of shader compute power. Okay. So after those are both finished, I need to actually build out the combined noise. And they should have the same values in them. The same number of values, rather. Just take the higher value? Is that what I'm doing? Yeah, and this is without stretching the cheese noise. The cheese whiz. Or the noodle noise, which maybe I can do here. Equals noodle noise. Wait, how do I stretch 3D noise? I'm actually kind of confused now. I think I have to do that in the shader. Yeah, I think I have to do that in the shader. Yeah, I need to multiply the world vert position. Okay, so I think I need an additional parameter in here. Or what, like position multiplier maybe? No, it needs to be a float 3. And so can I just pass in? Oh no, I have to translate the noise params position multiplier. It needs to be a float 3 because I need to multiply it on each axis. Yeah. Okay. Which means I need to update my noise params here. Oh boy, is there a lot. Okay. F vector 3F. Yeah, just 111 by default. And then in the noise generator header, which is that in the height map generator thing? Where did I put generators? That's what it was. Here we go. This is where I needed it. Float 3. Position multiplier. Vector 3. Okay. Okay. A position multiplier. There we go. We probably should... Wait, does that go here? Height map parameters dot noise parameters. That needs to go in here as well. And this should just be 111 for everything, so that shouldn't make a difference. I'm not even going to put it in the height map generator. Okay, it's gonna complain about this though, so. Okay. Danielle, I'll need to add it to each one of those. Like, see what I have to do to like get this to like. Position multiplier. Okay. Okay, that looks good. Noise generator. Now let's actually times position multiplier. I guess we can do this below. Or rather, that needs to go in here. So I think position, we'll do that first because scale is just a float value. So that can only scale it uniformly. It can't scale it, it can't stretch it or compact it or anything. It's doing a lot with scale actually, which is in position. We'll see if that works. I think this is fine. I think this is fine. And so I think if I increase the X and Y, it will stretch it. So we'll see. We'll see what that happens. Ah, excuse me. Okay, do I have that all set up? And I guess we're just going to take the max? And what I'm saying above 0 is solid space, right? I'm saying above, yeah, noise value above 0 is solid space. Okay. So yeah, I think I would want the max. Well, no, I think I want the min because I want it to cut through. I want it to cut through. I want the inverse of this, actually. Zero is, or below 0, or effectively greater than or equal to 0. Wait, does it have to be? I think I just want greater than 0, don't I? Otherwise, it's just not less than or equal to 0. Okay, okay, no, it's actually equal to 0 is actually okay. Solid space. Wait, less than or equal to 0. I'm getting so confused right now. If noise value is greater than ISO level, it is solid space. I think I maybe am calling that something wrong. We'll figure it out. We'll figure it out. If it looks bad on men, it'll be max. So we'll see what that ends up looking like. Okay, so I need to rebuild this, and then I need to create the new set of noise parameters. Okay, so I'm gonna try to get this tested. I just need to copy over some noise params and then add that to the endless terrain. And then I guess just run it. Oh, look at that little fat bird. Little chunky boy. Did you figure out how to squash the noise? Yeah, I needed a multiplier. A float 3 multiplier baked into the shader noise generation. Can you give me a line number? Attempted to read an uninitialized value. Can I get a line number, my friend? Okay, so it is in the height map generator code. Instructions should not read an unbound value or something like that. Of course, that's given me some, like, line number that doesn't mean anything to me. I mean, maybe I should just comment that out. So I'm not using that, which means I need to get rid of this one down here. Does that build? But yeah, I just needed to multiply. I just needed to pass in so I have like a scale, but it's just a float, so that only can scale it uniformly. I need to scale it ununiformly, so I passed in this position multiplier. Okay, it still doesn't like that. Do not read uninitialized value. Okay, so I guess that's because I'm passing it into the thing. Can I initialize it in that struct? Is that good? Do you like that? No, we don't. No, we don't get past that. Okay, so you can't. They can't have default values. Well, that's great. Love that. Okay, I think I need to add it to everything. To every one of these. We're gonna try this now. May not be able to finish this before I have to go. And we'll be leaving here in about 15 minutes. We may need to see the fruits of this labor next stream. Okay, those are added. Let me add it back into this part up here. Okay, is that what you wanted? Kind of confused at structs in shaders. Nope, something else is wrong. Oh, shit. Oh, I just pasted that wrong. Go back and redo all that. Okay. Sixth time is the try, you know what they say. It. Type float of shader parameter. Float 3. Did I make it a float up here? Oh, I did. There we go. We did it! Oh, we got past. Yay! Okay, so let's get those noise params copied over. We'll take a guess at what the stretch values should be. Yeah, so these are going to be the params we want to copy over. So let me look at endless terrain. Let's duplicate this. Let's call this cheese noise. Cheese caves noise params. We're going to call this noodle caves noise params. Okay. Open that up. And this is why I have this material, so I can throw things in here, see what it looks like, and then copy them in here. We want the gradient function, which will be 1, 2, 3, 4. Function 4. Turbulence is yes. Quality doesn't matter. Levels we just do 1. Min 1. We may be doing this backwards. And then -5. Level scale 2. Okay. Rest of the stuff doesn't matter except for the position multiplier. Let's just scale it by 10. A nice easy number in both directions, and we'll see how flat we get. Okay, and make sure I have that selected, and then pop that in there. Noodle caves. Alright, let's fucking do it. Uh-oh. Your deal? I don't need you, you're just a test, but I think I can fix you real quick. Oh, no more height map data. Goodbye. Running it. Okay. Oh, I reserved. I didn't init. Oops. So, I mean, the shaders ran. I don't know if the noise was correct or not. Let me make sure. Okay, that still got passed in. Perfect. Well, I think that went the wrong direction. That seemed to stretch it vertically. Okay, so I think maybe I need the max as well. Let's see what max looks like real quick, and then I'm gonna change the... Okay. I think is the GPU XYZ flipped? Like, is Y actually Z? I hope not. If not, maybe I just need to apply some Z. Ah, okay, that's a lot. That's a lot of noise. Yeah, I do know it's flipped in comparison to different engines and stuff, but the GPU should be somewhat different because it is an Unreal shader file. Okay, let's do 1110, and I'll be right back. Okay. Got a few more moments, then I'll have to go. Okay, I do see noodle-ish things. It's almost like too much. Just do times 2, maybe? Yeah, I think it's, I think I need better noise. I think that is technically, like, that is technically the noise, right? But it's just, this is solid space, right? So it's just making solid space, like, float. Should I think I maybe should invert that. And it's just completely taking over the other noise. So I think maybe I need like the average or something, maybe? I don't know. If I took the average, what would happen? Yeah, this noise ain't this ain't too good. Yeah, I'll have to iterate on that a little bit more, but for now I'm going to be hopping off. Yeah, this was a greatly productive stream, so thanks everyone for being here. Let's see if we can is there anyone we should raid? No, there's not. Okay. Okay, so I'm gonna hop off. Thanks everyone for joining me today. I need a break, so I need to hop off. Spent some time with my dogs. They're getting quite ferocious, if you know what I'm saying. Yeah, it was great. Thanks everyone for stopping by. Ice Krieg, Bruce Malt, Reanimated. Thank you all. Yeah, Reanimated with the bits as well earlier, so thank you. Yeah, this was exciting. So more cool terrain generation stuff on the horizon.